Have you ever wished you had a time machine so you could peek into the future? Or maybe even explore alternate universes? Well, now you do, at least for your network. Meet Crosswork Planning, part of Crosswork Network Automation, your network time machine. How is this magic possible? We're glad you asked. Crosswork Planning starts by gathering all kinds of operational data about your network, both from the network itself and from outside devices. It uses this data to construct a highly accurate model of your network, including topology and traffic. Crosswork Planning uses this model to become the crystal ball for the network. Wonder what will happen if you add a new service and if it will cause congestion on the network? Using the power of predictive AI, future changes will be accounted for and necessary mitigation steps can be taken. Capacity planning and predicting hotspots are now a cinch. Remove guesswork from the equation and make precise investment decisions backed by the power of big data and AI. The Crosswork Planning model also lets you visit alternate versions of your network and conduct what-if analysis from the comfort of your chair. Observe the resiliency of your network and explore what could happen in the event of a link or device failure to take preventive measures. Or you can test different capacity planning scenarios. Does adding bandwidth or new hardware help you meet and keep service level agreement requirements? Thanks to having the right tool for proactive network engineering, you can now peek into the future and know what would happen if, for example, you added a new high-bandwidth streaming service to your network. Capacity planning, traffic engineering, and network engineering all just got way more accurate. Your network manager can now sleep soundly at night, knowing the network is built to handle the future. To find out how to get your own time machine, head over to goto.cisco.com/crosswork planning.
Two, one, go. Hello, guys. My name's John Malooly, and welcome to Developer Days Day 2. This is the operations track for developers, and we're really excited to share a tremendous amount of information with you about our Crosswork portfolio from an operation perspective in terms of how you would use these tools to manage and control your network. We have a great set of speakers here today. But before we go into the agenda, let me just introduce myself properly. I'm a distinguished engineer. I work in the field organization, so customer facing. So a lot of my day is spent talking to end customers and users and operators for Cisco. I'm also the lead for transport slicing, which is something we talked about last year. that we delivered in the 6.0 release of Crosswork Network Controller. So if anyone would like more information on slicing, please reach out to us. And slicing is something that's delivered as an automation service as part of our toolkit. So with that, let me also just remind you that there's a survey for yesterday, and please fill that out and tell us how we did. It's very important that we continue to get feedback so we can improve. We've been doing these developer days for more than 10 years now. We're always looking to improve the content. So again, we have a great set of speakers today. A lot of focus on different aspects of the automation portfolio, from network controller to planning, workflow management, a lot of how to use the API functionality, element management. But I have the first session is really probably the key kickoff, because everything in the industry these days is about AI, and this gentleman, Javier Antich, actually wrote the book on how network cloud engineers can use AI to better operate our networks. And so Javier is a principal PLM out of our provider connectivity group, and he recently joined Cisco, and we are super fortunate to have him on the team. And he has a wealth of experience on machine learning, analytics, observability, and again, he's going to kick us off today. Please don't forget to use the chat and the Q&A bars. There are experts online that will field your questions, and after each session, there will be a few minutes for Q&A. So with that, why don't we jump into Javier's session? Javier, welcome, and thank you for presenting to the team here.
Thank you, John. Thanks for having me on this operations track, and very happy to share my thoughts to the audience, to the people joining us today. So let me see if I can share my screen again. Okay. Hopefully you guys can see my screen, and again, very happy to be today on this conversation, which of course, as John introduced, right, is about AI, which there's been already some of that on the event, and you're probably hearing about this constantly in the industry. But I would like to take this conversation today a little bit more personal, right? I don't want to talk to you about this as you being part of an organization. I would like you to listen to this as being a network professional, as a network engineer, and how this might impact you also in your next steps, right? From a professional point of view or personal point of view. Why are we talking about AI so much these days? Well, in a good part, because our industry has set a very ambitious goal. We've been talking about this for a number of years, but now it's becoming more and more important than ever. How do we get to the autonomous network? We had yesterday a few conversations around the overall idea of the autonomous network and what it means, and several forums like TM Forum, Etsy, IPUT, and others are really pushing towards make this ambition real, in very similar definitions and very similar approaches, but definitely the forces are aligning towards how do we make this real in our industry. And why this is happening right now? I mean, why so much emphasis in making the autonomous network a reality? Well, one way to look at this is because we all are in the middle of a perfect storm. And somehow that perfect storm is the confluence of a few factors that are feeding, each other, right? First of all, the networks are more complex than ever, and we could, view this from multiple angles, whether it's a scale, whether it's, number of devices, services, et cetera. So the complexity is higher than ever. But at the same time, the expectation from your end users, right, are higher than ever about, the performance of that network, measuring there's no performance or reliability, response times, anything that can be used to measure the behavior, the performance of that network, the users expect more because, for practical purposes, our lives depend on the network these days, right? And then, on top of that, the resources that you all have to manage these infrastructures are more limited than ever and probably even trending down. So this results into an almost impossible situation, this sort of perfect storm that we and you need to navigate through. How do we navigate through this? Well, the answer is basically what we all do these days, especially in this community, which is automation. But it's taking automation to an unprecedented scale. That unprecedented scale is what we call the autonomous network, right? And is it just about doing more of what we have been doing, like running more workflows or running more provisioning processes and so on? Well, definitely we have to do more of that. But it also means starting to do things that we haven't done before, right? That's what will take us really there. And what is it that is missing that we need to start addressing? When we look at any process in our life cycle of the network, right? There are decisions and there are actions that are executed associated to those decisions, right? From a network automation perspective, we've had primarily a focus on automating actions. We have built tools for that, built orchestration tools, workflow engines, provisioning tools. We've been talking about all those tools these days and what is possible. But the main focus of those is on how do we automate actions. The decisions that surround those actions are still highly dependent on people, right? They depend on knowledge. They depend on reasoning, right? And of course, they also depend on data and algorithms. But if we need to scale automation as a whole, and we continue focusing on automating actions, the decisions associated will become the bottleneck because the humans are the bottleneck in that context. Can we scale the human component of it? We cannot. Definitely, we cannot multiply the amount of people that we have managing or operating networks. That's just not really feasible. So what can we do? Then we need to find a better way. We need to find a different way in which we can use technology to help us make more decisions, better decisions, and faster decisions. And this is where AI will help us. So back to what I was mentioning earlier, why are we talking about AI now if this is a network automation community for the most part? It's because AI is just the natural enabler for the next phase, for the next era of network automation, where we embrace not only automating actions, but also automating decisions, right? And as network automation engineers, we need to start embracing that part. Of course, there are certain foundational building blocks that need to be there to be able to start addressing that decision component, the decision layer. And those foundational building blocks are those that enable us to get the proper insights and those that enable us to automate the actions, as I was saying. So it is about insights, decisions, and actions. And the foundational building blocks, we have already, laid them out with our crossword automation portfolio that enables us to provision services, to automate workflows, to analyze and visualize data, and provide assurance for services. So all this cycle, it's already there. That's the foundational building block. Now is how do we extend this foundational building block with AI to be able to get there, to be able to get to the autonomous network? Where does AI really help in this context? On one hand, AI will help us get better operational insights. So transform data, raw data from the network into something that is more useful. And there are multiple algorithms and multiple use cases. We'll see some examples. Once we have the insight, what we want to do is to make a decision with that insight, right? So AI can help us also to accelerate and automate those decision processes, precisely the bottleneck that I was referring earlier. But then once you have a decision, you really want to transform that decision into an action. You want to enforce the consequences of that decision. And you need, tools to transform those decisions into actions that will be able to automate those actions. There is also opportunities where AI can help us make it easier to automate those actions. So as you can see, AI helps us in almost the entire process in one way or another. If we double click a bit on the insights part, right? I mean, it is clear, and we all know that you can't improve what you can't see. And that starts by being able to collect the right data from the specific sources that generate. And I will not go into the details, but we have all of different options in our portfolio and technologies to get the right data and the right granularity. But of course, that data is always contextualized in different domains and require specialized analysis to produce something meaningful. And that's the reason why we have domain-specific tools and systems that will allow us to analyze that data and produce the relevant insights in the context where they are produced and consumed, right? So some of the examples of our tools in our portfolio, right, will help us analyze and contextualize that data where they belong to. But then now, on top of that, especially for those cases where we need to start having a multi-domain, visibility and analysis, we have now that top layer framework that will allow us to merge, to consolidate data coming from different domains, both network-related domains or non-network-related data that might still need to be, brought together, right? So these are the key building blocks that will, facilitate building those operational insights that are relevant and necessary to get through this cycle. But what type of insights do we need, right? Traditionally, we've been focusing a lot in building reactive insights, those that help identify that something is going on and be able to fix it quickly, right? That's definitely useful. That means the problem already happened, right? Algorithms and data are available for us to take this further and be able to take a more preventive or proactive approach, build insights that will allow us to identify maybe that something is about to happen, or that there is a higher possibility that something will happen if a certain factor happens, right? Or that certain events are being greatly influenced by certain type of conditions, because if all that happens, then we can maybe reduce the occurrence of those network incidents. So that's, the very next step that we can take. And taking this further, we can use data and algorithms to be more prescriptive, to build knowledge that will help us, more, adequately to the specific context, operate, configure, and evolve the network infrastructures based on the knowledge generated with data. So there's a number of examples on this slide. I will not go into the details. We can, I'm happy to go through more and, double click on any of them if you guys are interested at any point in time. But all these are areas and use cases that we are working on, and we have prototypes. But I want to show you one just to illustrate an example of the potential that analyzing data brings us in the context of network operation. Right? Configuration drifts or configuration anomalies, it's a constant challenge, right, for any network operational context, especially for those cases where, there's still the possibility to change the configuration manually, right? We have been dealing with this type of challenge with templates, with golden templates that you have to define and then, run against, those configurations. But there are challenges as well associated to creating, maintaining, and applying those templates. So machine learning gives us the possibility to take a complementary and alternative approach, which I'll quickly describe, right? And of course, the context, as I said, is that there's still a lot of people and a lot of contexts where changing the configuration through the CLI, it's still a possibility that it's allowed, that is permitted. And if that happens, that means there is a possibility to make mistakes. So we want to identify, hey, is there any anomaly? Is there any deviation in a specific configuration from what it should be? But we don't want to do it in a way that the system somehow can automatically understand what is the right or wrong configuration in a specific context, right? Not because I tell explicitly via certain templates, but because the system might learn automatically that knowledge from the actual configurations. And this is an example that we have been working on. So you can train actually a neural network model, what we call a configuration language model, with the actual configurations, right, from a network, whether it's Cisco configurations or any other vendor configuration. It's really agnostic from that perspective, and be able to detect anomalies in case they happen, in case there is a configuration that doesn't fit into what the model has learned. And in doing so, we can actually detect both cases where there is something misconfigured that shouldn't be there, like maybe a wrong MTU, or whether there is something missing in the configuration that the system thinks it should be there, or whether there is something extra that shouldn't be there as per, the knowledge that the model has learned. So again, this is just a quick example of the possibilities that we have by analyzing different types of data from the network, in this case, configurations, and turning that into relevant insights that allow us to make decisions. But now let's jump into the part that I think now is really the one that has the most potential, which is how do we use AI to accelerate decision processes? The insight part is relevant because once you have the right insight, then it's easier to make the decision, but still someone has to analyze the data from different sources and make that decision. So how can we really accelerate and facilitate that? There is a very interesting phenomenon going on, not in our industry, worldwide, across all industries, with this idea of the AI agents or autonomous agents. And this is really revolutionizing industries, many of them, right? These are just examples, but there are so many these days, right? Examples from a data operations perspective or from a sales operation perspective, right? Autonomous agents as entities that can make decisions and help us take automation of different processes to a next level. And when we start thinking on the analogies, right, to our industry, the potential is, significant. What is an autonomous agent in practice? Well, you are all familiar for sure on what a language model is, what an LLM is. An LLM is basically mathematical functions. It has no life or no proactivity. You just introduce something that we call a prompt and you get an output, you get an answer. That's all it does, right? So it doesn't have by itself the ability to solve complex problems because it's static, right? It's passive. But we can use a language model to build software systems that actually have, a more active behavior. You can use a language model within a software system as if it was the brain of a system that can self-plan, that can, execute on a plan, that can run certain functions and action that is enabled to do, right? That can even self-critique what it is doing or whether what it is doing is right or not. And it has short-term and long-term memory. The consequence of this combined is that these are goal-seeking entities. You can request an agent a complex problem, and the agent will solve it. You don't need to tell how to solve it. It will figure out automatically the plan to solve it based on the knowledge that this language model has and based on the context that you provide. But ultimately, it self-plans and it can autonomously execute. So we start seeing, one entity that can autonomously execute complex problems. This sounds very interesting for our autonomous networking vision. And even more, when we think that we can combine multiple of these entities, multiple of these agents together, right, in multi-agent architectures that can solve even more complex problems. Right? So this is revolutionizing, whole industries. And when we think about this is going to impact us, and it's going to impact you as a network engineer. So you need to start not only being aware, but also being very familiar with how this technology works and what's the potential of this. A few months back, early this year, on this NVIDIA event, Jensen Huang, the NVIDIA CEO, was talking about his view of what is the future of software development, right? Software development as an activity, as an industry. And he literally described it like this, right? You will assemble a team of AIs, which means agents in this context. One of those agents will take the mission that you want, your goal, and will break it down into an execution plan, right? And then each of those steps from that execution plan will be handed off to specialized AIs, specialized agents, to effectively go and execute them. This was, early this year, it was described as the future of software development. Well, it's already the present of software development. There are already systems that are building software using this type of approach. And, in many cases, the performance and the results are really impressive. There's still a lot to improve, but we are seeing that future is already now, right? So if we take that to our scenario, to a network scenario where we have a network engineer dealing with multiple systems, right? Automation tools, AI ops, inventories, and all sorts of monitoring tools on top of the network infrastructure, whether it's network or cloud or both, right? Whenever that network engineer has a request from someone or needs to deal with a situation, these are all the systems that that person needs to interact with, that you need to interact with, and you need to know how to do that. And each of those interactions is time and cost, of course. This can evolve over time to that alternative scenario where now intelligent agents, autonomous agents, help us accomplish those goals, right? The agents know how to interact, how to deal with all these different systems, and can help us automate processes that otherwise will require us, going and finding all that information directly, including potentially diagnostics and troubleshooting. So as we move forward in this journey with AI agents, the decision processes will be accelerated by the agents that will help us obtain the information we need, and probably initially we will make the decision that we need to make just faster, just by the fact that the data that we needed to make that decision came more reliably and faster using agents. But in a subsequent step, those agents will collaborate with each other to provide a more curated view that will help us actually even accelerate further the decision process. So this is likely going to be the future of how we will operate moving forward network infrastructures, which logically we could represent in some way like this, right? We have all, maybe this, and it's not super exhaustive, but these are maybe the most significant functions that we have in our operational ecosystem to deal with our network, right? We have, or maybe assurance stack with real-time analytics or incident management tools or workflow automation tools or controllers. And all these systems have flows of data either up, towards the human layer to get the data and interpret, and down as the flows of, intent push or operational state change. But now there's going to be a new layer coming up, which is that autonomous AI layer that sits between the humans and all these systems, and will help us, will help abstracting the complexity of dealing with all these systems, because the agents will know how to do that and will help us execute complex tasks in a way that we can really truly delegate some of those tasks to the agent. And over time, more and more of those closed loops that we also always have the ambition to create will be closed at the agent layer and not so much at the human layer in the future, helping us, approaching those TM Forum level 4 or level 5 levels of autonomy, which are, or let's say, industry ambition. Some examples, and we've been working on this technology for some time, and we see how, this is progressing both from a perspective of the logic to build the agents and from a perspective of the language models that support these agents. But let's take the example of an environment where we have, provider connectivity assurance, and we have an agent that helps us get, more directly and quickly responses to certain questions that we might have. Again, this is just an example, but let's say we have this situation where we got an alert associated, with a specific object, with a specific entity that we are monitoring, and we need to know if over the past 24 hours on a certain metric associated to that object there's been any anomaly, right? And have a view of why those values are anomalous. We never told the agent how to do any of this analysis. We just have enabled the agent to know how to call the specific REST API that gives you the ability to query a certain metric, or any metric for that matter, and the agent can query whatever metric is asked to eventually. But in this process, when I made this request to the agent built a plan autonomously about how to respond to this question, got the metrics from the system, analyzed the metrics by itself, and came up with a way, which in this case is the C-score, which is just a statistical measure to identify if there are anomalies on any of those specific values. So I never told the agent how to do any of this. The agent figured out based on the context and the type of request that I gave and the tools and functions that I enabled the agent with. Similarly, we can use agents potentially for more complex problems, more distributed problems, like a troubleshooting of network issues. In this example being, hey, a BGP session is down, why it is down, right? So we can have agents working collaboratively, a diagnostic agents that is focused on the diagnostic plan, on the troubleshooting plan, and search agents that are focused or enabled to actually go find the information that the diagnostic agent need for any of those steps in the troubleshooting plan. So collaboratively, they can actually go and respond to the questions that we have requested. In this case, the reason why the BGP session is failing, right? So this is not production deployable yet. It will probably not be a use case like this, network troubleshooting, network-wide troubleshooting, for the next months or year, but it's really around the corner, the time that we will be able to get this type of use case to production quality. As per TM Forum, a few months back, they released what they call the blueprint to make level 4 autonomy real. And in that blueprint, they really highlighted the role that autonomous agents will play in getting there, in getting to the level 4 autonomy, both single agent use cases as well as multi-agent in a subsequent phase. So this is really going to become the concept of agents and multi-agents. It's going to become a really key component as in the way we operate and we manage networks moving forward. So I think it's important that we all get familiar with it. And ultimately, what is it that we're doing, right? When we are addressing, operational problems with this type of techniques? Well, we are actually unlocking the long tail. If we sort of visualize most of the activities that we do in the context of network automation or network operation, there is always this long tail shape where, for the things that are more frequent, traditionally, we have created rules. We have created templates. We create, different types of, artifacts that help us deal with those situations that are more frequent or maybe we consider more important. And those are well covered. But what about the rest? What about the long tail? This is where we spend most of our time because those are not automated. Those are not managed. So we have to spend our time troubleshooting the issues that are less frequent, correlating the log messages or the events that are less frequent, or dealing with those situations that we haven't automated yet. Autonomous agents and basically the opportunities that AI bring basically will help us address that part of the long tail that otherwise today, most of the time, it's uncovered. So when we think about the future of network automation, and think of this again based on your personal, the impact that will have in you personally, right? Today, we encode our knowledge somehow in rules, right? We create one rule or one rule set for every use case that we want to automate, whether it's a closed loop use case or any other type, right? And this is fine to ascertain a scope, to ascertain limit, but we cannot go beyond this level 2, level 3 of levels of autonomy, right? Because it's impossible to manage so many different rules and templates. This is going to evolve to a scenario where agents will take that additional role, where we will teach agents skills that will allow the agents to interact with all the systems, right? And given the right context and the right goal, it's the agents that will actually enable those use cases, those closed use cases based on what they know and the context of people. And this is what will take us from level 2, level 3 to level 4, level 5. And what's in it for you, right? What's in it for you personally? I think as a network engineer, you have to understand AI/ML to at least the point to recognize where it is applicable, where you can actually identify the opportunities, right? And where you can have a critical mind, not to necessarily believe blindly what we vendors maybe tell you, because there will be cases where you might receive messages or solutions that actually not realistic or not really doable, and you need to have the critical mind to understand what's real and what's not, what is the art of the possible. So I think for you as a professional, as a network engineer, you have the opportunity to expand, to move a little bit towards that gap between networking and data science. Right? The goal is not really that you should really be a master in data science, right? That's not really necessarily maybe it's not even a good idea, right? For sure, if you want to, do it. But I think expanding your skills to have a critical mind and identify opportunities will make you a better professional. But also as an automation engineer, you've seen the new arena of automation are the decisions. There's going to be new entities to manage, to create, and to deal with, which are the autonomous agents. They're going to be based on language models, and they're going to be, based on algorithms that will enable take, more advanced decisions. You have to be an active participant on this process, right? Because that's the natural evolution of network automation. So I hope you've seen over, the past 30 minutes or so that, when we talk about AI in this context and when we talk about autonomous network, it's not just this hot topic of the month. It's just the business, imperative on how do we navigate through the perfect storm. And you are in the middle of that perfect storm as well as a professional. So I believe it's important that you guys, get yourself more familiar with these technologies and start applying where it makes sense. So that's pretty much what I wanted to share today with you guys, and happy to take any question later.
Hey, Javier, that was great. I mean, I got a bunch of questions myself, and we're getting some from the audience. We're not going to have a lot of time here for a lot of questions, but
yeah,
I guess one question from the audience is and you had some examples in there, but a lot of the service providers already have automated actions, and this is kind of I think what you just touched on at the very end of your session. You have automated actions, but they're not at the decision stage yet. So is there a specific where would you suggest these guys get started? And certainly I think it's already in some of our products today where there might be a recommendation that's spit out, and then it's up to a human to decide to either execute on a recommendation or not. And once they get to the point where they're just hitting the button, yes, 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 I think that's the stage where they're comfortable enough to make it automatic. But is there a use case or biggest bang for the buck spot where they should begin to look to do some of the experimenting that you just went through?
Yeah. I mean, definitely, as you say, right? I mean, even in many cases, we might not even trust in automation, as we know it today, right? Sometimes people are still reluctant to automate. So, even more to automate a decision or to let a system take a decision. So in that sense, I think we need to go step by step. We need to build that trust progressively. And there are definitely use cases that are, like facilitating making complex questions from the network, getting insights, right? Or getting, ad hoc reports where you have a complex query, a complex, data that you need from the network, and you can let the system decide how to give you that information, right? I think these are the main type of use cases, like read-only, if you will, that we need to start to basically build that trust. And then, of course, any use case that is associated to making a decision that results into an action back with the network, make sure that we have human in the loop so that we can progressively build that trust. In parallel, technology is going to improve so that it will help us also increase the quality, the accuracy, right? The success rates of all these decisions, so that we can also measure them and provide you transparency in that process. So I think collectively we will need to make different steps to make sure that we get to a point where we trust enough in those decisions. But I think read-only use cases like queries, reports, etc., are a good place to start.
Yeah, and I know we're a little over here now, but just the art of the possible here, meaning segment routing technologies, SRMPLS and SRv6, have the ability to really provide surgical routing, path forwarding for different types of traffic. So, I can see a lot of use cases where kind of proactively, kind of like you said, not reactive, but proactively, that the network could move traffic before, congestion events happen, due to, historic data. In fact, there was one customer who highlighted that, whenever they had a transport failure, they could see that the optical power amplifiers were degrading for months. So there's plenty of things
Exactly.
we can begin to do that I can't wait to see what happens in the next couple of years. But let's we got to move on now. So thank you again, Javier. So I would like to introduce Paula Orozio. She's currently the Director of Product Management in the Provider Connectivity Group. She came from the Pirelli acquisition, which was 25 years ago, but I guess you can tell from her accent she's from from Italy, and she's got a wealth of experience on service assurance and manageability, and she's going to present how to simplify the infrastructure with visibility and control. So Paula, thank you for helping us out here.
Hey, thank you, John. And yeah, you mentioned Pirelli, and that came to me with a famous commercial from Pirelli that was saying, "Power is nothing without control." And your network is becoming more powerful and more complex, so infrastructure visibility is going to be vital for a seamless experience and enable advanced closed loop and autonomous use case that Javier just presented. It's how you manage a complex network with easy. In today's session, we are looking how we are simplifying infrastructure visibility and control, so it can be accessed by every operator that actually have a router or switch in their network. In the spirit of simplifying the operational journey from EMS, NMS bottom-up approach to the intent-based approach that qualifies the controller, we have added infrastructure visibility as part of the cross-network controller. We add this in a way that can be easy consumable by every operator that, as I said, has router or switches in their network. Here, what we focus on. We focus on quick adoption. Installation is quick and operator can add instant value, adding deep visibility of the infrastructure down to the specific of port and pluggable, as well as a complete visibility of the physical topology. We provide pre-certified coverage for Cisco hardware and OS and multi-vendor coverage for third-party vendors that align to standard implementation. It is true that every vendor implements standard with variation, so we open up for customization through professional services. The device lifecycle management functions are fully integrated so that operator can benefit on a seamless experience and can contextually drill down from hierarchical controller to the cross-network controller and the related detail of device, module, port, pluggable interface in a contextual way. What does it mean, quick adoption? Well, we have single VM form factor to simplify the installation and have instant support to up of 1,000 devices. The single VM form factor will be available for all the controller function, also starting in with the cross-network controller 7.1 that is actually planned for mid of next year. So also customer with a limited set of device can enjoy full visibility, and we can set them up to expand to the controller. If you have more than 1,000 devices, the integration with cross-network controller allows us to leverage on the cluster architecture and hence expand and increase to add cluster as additional devices are added in your network. Current support is up to 50,000 devices. We are going to increase to 25,000 devices in the next release, and we are growing more in the upcoming release. Inventory, topology, fault, and metric API are available on the UI and via API for easy integration with your ecosystem. On top of classic device lifecycle management function, we may enable also zero-touch provisioning to simplify the device onboarding. We are supporting different mode of ZTP, and we have also hosted a day zero configuration repository. Key functions like zero-touch provisioning, software image management, export API for integration, as I say, with an external SOA system, but also with the rest of the Crosswalk portfolio, including Crosswalk Workflow Manager, that will be soon fully integrated with the Crosswalk Network Controller, enabling, as a first use case, a fully integrated support of fleet management across not only Cisco, but also third-party devices. Let me go through the functionality that are available today and will be available in the next few months. Starting from device inventory management. Device inventory span horizontally, giving you the complete inventory of the network down to the pluggable detail. User can simply search for device type or product identifier to have the full view of the specific entity in the network, how many, where they are, and actually provide also reporting to the inventory system. Device inventory span also vertically, giving the user the detailed containment tree of the device, module, port, pluggable interface. The approach is done in a way that the same representation is going to be leveraged for Cisco and can be extended to third party, relying on the standard support. We have a complete coverage of device inventory, including, as I said, zero-touch provisioning to simplify the device onboarding. The details of the device are fully discovered. The user needs just to add the IP address to onboard the device. Of course, we cover also connectivity topology to provide the visibility of the connectivity on the topology map. Going over device image and configuration management. Basic atomic operation like image download and image activation are provided as part of the essential offering. User will be able to perform this operation on a single device or in a bulk immediately or by scaling the operation. The image upgrade perform some basic verification like device is up, space on the device is sufficient. But if user wanted to implement a full pre-check and post-check of the image upgrade, then it will leverage on the Crosswalk workflow that allow to create the sequence of tasks. Indeed, the download task and the activation task are addressed leveraging the API available as part of the device lifecycle functionality, as I said before. We are adding also other function in the Crosswalk Network Controller 7.1, like configuration, backup, and restore. This again is to provide a complete set of functionality for lower tier deployment that want simple out-of-the-box use cases. Underlay configuration, it's another functionality that will be available in Crosswalk Network Controller 7.1. Include the ability to push template-based configuration across the selected device and help to do that infrastructure configuration required to bring up the device and make it ready to end-to-end provisioning, like configuration of protocol or configuration of DCO wavelength. To complete the visibility of the infrastructure, we provide also device fault management. So we are normalizing the duplicating event and trap that and raise alarm accordingly. All event and trap that come from the router and switches. Alarm are enriched with inventory information to provide context on where the alarm is. The same context is used to provide the alarm status view and enrich topology and logical view of the containment dependency to help the operator to visually quickly identify which is the high severity alarm and which specific entity, port, card, device, pluggable interface is alarmed. Of course, all defaults are streamed to an external system for integration. In case of lack of connectivity, we have API to allow to retrieve alarm, raise and clear during the connectivity lost. Last, on fault management, we completely manage the device lifecycle of alarm, like hack, unhack, and add note. One of the major additions we add in the cross-network controller 7.0 is the ability to collect specific parameters for each object we manage. Again, these include the device, port, pluggable, interface, and connectivity link. As we say, telemetry brings in a large amount of operational and performance data in real time. This enables a near real-time visibility of the network, but we've overwhelmed the operator. Instead of collecting everything at this level, we are monitoring only those parameters that are important to understand the health status of the infrastructure. We are keeping history of those metrics to simplify troubleshooting, and we are exposing API to ecosystem integration. The frequency of collection at scale is around 50 minutes. Again, the goal in this case is to have a view of the health status of a specific object, port, module, pluggable, interface. If the goal is to analyze metric and proactively identify patterns that may cause degradation, this is done through provider connectivity assurance that provide proactive service quality analytics and give us unprecedented visibility on the service flow through the network. All those functionality are fully certified for Cisco OS, XR, XC today, and we are extending to the Nexus OS to provide a single pane of glass across all the Cisco OS, playing a role in the transport SDN and data center connectivity. We provide basic multi-vendor support if the third-party vendor is aligned to standard MIB. And we can extend to the complete coverage via CX customization, leveraging, if it is actually the case, proprietary implementation of the third-party vendor. These functionality are completely certified with Cisco solution and innovation. For routing optical network, we can provide detailed inventory of the pluggable for capacity tracking and planning. We can visualize key optics metrics like FAC, BER that are important to derive the quality of the circuit. Starting from the 7.1, we allow to perform a configuration through template, as I said, that we help customers that has a low number of DCO optics and today use a CLI for basic configuration to be error-prone while gaining a visual view of the status of the pluggable. For automated assurance, we have seen how we can complement service health and policy health with infrastructure health. By bringing in inventory, fault, and performance, we want to help the operator in clearly identify the physical component that may be cause of a service degradation. Instead of proceeding bottom-up, trying to understand which service is impacted by a specific failure on a port, we can extend drill down from the service impacted the specific physical component detail. We can see all the alarm and event that are on the specific device supporting an impacted service, and remove from the operator the noise related to alarm of other device not supporting the specific degraded service. For sustainability, we are collecting and keeping history of device sustainable indicator like temperature, power consumption, and those are a prerequisite for advanced closed loop use case like power consumption reoptimization that are going to be delivered by the cross-network controller. On 5G transport lines, we provide complete visibility on the infrastructure, not only Cisco, but also third-party device involved in the slicing. We have demonstrated last year at ENTC how we can provide complete coverage of a slicing lifecycle through the cross-network controller advanced functionality and the infrastructure visibility across a multi-vendor network. Last but not less important, we provide full device lifecycle coverage for the metro architecture device. The target is to provide coverage within 3 months from the OS general availability. Those functions that we have just seen are completely integrated in the cross-network controller. The way we have done it is to leverage on key device lifecycle function as microservice and integrate that in the back end. while we completely rework all the workflow. So the user can have a complete seamless experience from the controller function down to the device lifecycle management function. The goal has been to avoid to have operator to switch share across different tools and provide also a seamless integrated workflow experience that connect service, path, and infrastructure component, aligned to the top-down approach that we have on the SDN controller. Standardization on the same platform also allows us to simplify administration with a single approach to not functional requirement like RBAC, GUHA, and as well as deployment model like simple VM or cluster deployment. Moreover, we are integrated with the Cisco portfolio, and the goal is to enable contextual drill down and avoid to actually have user to switch share across different tools. I actually use a simple video just to show this concept. Here you see the hierarchical controller. The hierarchical controller gets information from the different domain controller, and part of those information are the inventory of the different object, device, link, module, interface, as well as it actually gets all the information related to the health status or operational status of these different components. Through the view of the controller, as we say yesterday, we can simply identify which is like the link that is going actually to be impacted because I actually have, for example, an optical link degradation. Through that, I can actually drill down. It's like a cross-network controller and the hierarchical controller are completely integrated. So I can contextually drill down from the link representation on the hierarchical controller to the link representation into the cross-network controller. Let me go a bit quicker. So here we are seeing, that one entity is actually now alarmed. And we can see that, we can actually drill down and actually understand, the reason why it is actually alarmed. This is like the view that we have on the hierarchical controller. And now we are moving to the same view that we actually have on the cross-network controller. I'm going a bit quicker. Here on the cross-network controller, and I will go into the detail, you will see, all the detailed information. You will see that the link that is alarmed actually have an overlay icon indicating that there is like a problem on that specific link. If I actually select the link, I can see, the different links that are composing that one, and which is like the status of the different link. Then I can actually see also that there is a overlay icon also indicating which is the alarm status of the device. So on the bottom end, one is like the one that is alarmed, and here I can see all the alarm that are actually related on that specific device. So avoiding again to actually proceeding bottom up, but always starting from the context of the service, the link, and going down to the detail. We say also that we want to complement intent-based service assurance and policy monitoring with infrastructure visibility. So I'm going actually to use a view that I shared yesterday during the assurance session, and that will go through a short video reporting the functionality that I just described. I start with the inventory functionality. So here, of course, you actually see Italy because we have our lab in Italy. So here we see, that we can see all the inventory information, as I said, on the specific device that I have selected. All those information I can actually easily filter it out in order actually to understand which is like the different module that I have, pluggable and so on, right? Based on PIN number, serial number, and so on. Another information that I can have is like the device inventory view. As I say, we have removed the chassis view and we add a logical view. Why? Because through the logical view, we can actually have a representation that I can easily extend to a third party. So both we can provide the same view, both for Cisco and third party devices. So in this view, I can actually also decide which is like the different component that I want to visualize. If I want to see fan or power supply or so on, in order actually to simplify my overall view. What you see already in this view is like when we actually have a component that is alarmed, because I'm actually contextualize the alarm with the inventory information, I can report on this view, which is the component alarmed, and why then is going to be reflected on the high level view. Let me go on the fault piece. So we start from the same view. You see that each device actually report an alarm status, right? So we are reporting the high severity alarm that is on that device. That same information I can actually decide to report based on criticality on my topology view. In this way, I actually have a quick indication of the device that actually are alarmed or have components that are alarmed. I can easily drill down. I can see I have a quick summary for the device indicating how many alarms for each severity I'm actually having. So a more expansion on the status, and I can see all the alarm per the specific device. So I always drive top down, starting right from the device and the context. Of course, we know that, some operators still actually have, the use to have a full set of alarm view across their network. Well, that can be also provided, right? And through this view, we can actually enable what we said was the life cycle of the different alarm, like ACK, ANAC, add note, and so on. And for each alarm, as you see, I can actually see all the details of all alarm and also the event that has been deduplicated and associated to the alarm, as well as up and down. Let's see also the last point that is like a focus on the performance view. So for each device and component, we collect those parameters that are important to understand the health of that specific component. So in this case, CPU, memory, availability, and we collect also, as you see, environmental temperature in order actually to enable the sustainability use cases. The same information we report also specific metric per link. So at the element management level, we are reporting the metric that are collected at the endpoint of the link. So in this space, we are calling, the rate, the packet rate, and the packet drop. But if you actually have the cross-flow network controller, we are going actually to collect also information related to the end-to-end view, so jitter and drop from SRPM. Here we can actually easily search from a component. In this case, we are looking for a specific pluggable that is like an optics pluggable, just to show how we are covering their own use cases. So you see that from the search, you can quickly identify where the pluggable is. And here we can actually have, different the different information related to the pluggable that are actually both the Ethernet part as well as the optical part, like optical power and so on, and voltage, and this type of information. Let me give you another view, right? That it is let me move to the next one. Okay. So I want you to actually have also a view across the different vendor. In this demo, we are going actually to the functionality across Juniper, Huawei, and Nokia. We just have a couple of Cisco devices. So I want actually to quickly go through the same functionality that we have seen, basic functionality, inventory, fault, and performance. But here we are showing, you know, all the detail of the third party. There are some of those third-party information are coming directly from the standard MIB implementation. In some cases, when there is actually variation, we need actually to customize to actually get the information from the proper model that the vendor support. So in this case, actually, we are seeing, you know, all the alarm, the different status. We see, you know, the detail, the link information that we are seeing. In this case, we are seeing, you know, the detail of the device. Again, the alarm status. We can see the inventory with all the different components that are related to the specific device that we have selected. We can see the status of the interfaces. And then we can actually also review specific metric and parameter. So as you see, the same function that we actually provide out of the box for Cisco device can be extended to third-party device. And it really depends on the level of implementation of the standard MIB. Here, for example, you see again the logical containment view, and this explain the reason why we choose this approach to actually extend to also the third party in a seamless way, and to provide the same experience across Cisco and third party router. So as you see, all the function that I've seen before applied to Cisco, I can actually apply to the specific third-party box. Right now it's too small, so I cannot actually see which is the box between Juniper, Huawei, and Nokia. So you can see again, I can see, you know, all the specific information of the interface or port and so on, and the specific information at the port level. As you see, we are always contextualize the metric to the specific object that they are applied to. That is like to not overwhelm the operator to too many metric without giving, you know, the proper context. Again, in this case, as I said, we complete the view with the complete alarm list across all the network, as well as we are going to have later on, I believe at the end of the recording, also the inventory across all the network. And with those videos that my colleague Nicola provided to me, thank you, Nicola. So I want actually to conclude with what I said at the beginning. Infrastructure visibility is vital for a seamless experience. It's how you manage complex network with ease. So Cisco Cross-Flow Network Controller provide operator full visibility and control also of the infrastructure resources. Simple and quick to install. We have seen that it's simple to attach to your router and switch to gain immediate value. We have different deployment options that align to the scale need. It is fully certified on Cisco and eliminates the need of multiple management solutions through multi-vendor extension via standard support or professional service wherever the third party does not support standard. Allow to simply extension to full controller functionality. It is a stepping stone for all the Cisco innovation solution and architecture. And with that, I don't know how long I took, but back to you, John.
Thank you, Paolo. Terrific presentation. Got a couple questions from the audience that we'd like to throw at you before we jump over to Nicola. I guess one of the questions is, what do you see as, in terms of the future need for traditional, EMS systems? Because, what you presented here, is more controller based, which I think was part of our strategy and what we've heard from customers. They want to be more towards an SDN controller versus locked in with a single vendor element management system. It looks like we're now including a lot of those capabilities in our product here. So what do you think the future holds for traditional EMS systems?
Well, the approach that we are differentiating ourselves, right? Because most of the other vendors, they start from their existing EMS and MS and evolve that through a controller. Our approach has been completely different. We start from the control point and the intent-based approach. But then, as I said, we need to actually have also visibility of the infrastructure. So we add those to actually gain the visibility for infrastructure. So I believe that the visibility of the infrastructure, as well as the need actually to have clean data, right, as Javier was saying, is like needed. Anyway, we want an approach that does not start from the classical bottom-up, but it is actually completely integrated with, the controller intent-based approach. So I start from the intent, and then I'm using the information of the infrastructure to understand if the intent, if the status of the network is matching the intent that I have. So in that sense, I believe that is required, but it needs actually to align to the approach of the controller. I'm a big fan, right? I always say it's top down and not bottom up.
Right, and I think that's an important point, and I know we've talked about this in previous developer days, and I think Krishnan is also going to talk about it later with service health, meaning traditionally with controllers and orchestration in general, you start with provisioning, and then the service assurance is an afterthought, right? I mean, but operators are like, hey, I can't, it's great, I can provision, but if I can't actually do service assurance, I can't deliver this service. And I think what you're highlighting is now they're part of the same piece.
Yeah, they are not anymore an afterthought, right?
It's part of the service assurance is provisioned as part of the service itself, and it's integrated, and now you have the correlation across all the objects. So I think that top-down service-centric view is probably more important, right? Because it's about the intent.
It's always to reduce the overall mean time to identify, mean time to know, right? What we were saying is like, if you start from a failure on your network across on your view, right, that you actually have, all the alarm that you have on the network, right? You start with the failure that you need to understand, which is the service that is going to be impacted. Our approach is like, I'm using actually synthetic testing to tell you if the service is impacted. And then I'm giving you more information about the network instead of giving you, all the information possible and trying actually to have the operator to figure it out which path to follow.
Right. Well, that's great, Paolo. So thank you again. And again, it's amazing. I guess we're on release 7 of Crosswork Network Controller. So, you know, it's just every release we seem to be getting more and more functionality and you know, usability. So nice job from your team on this. You know, delivering on customer requirements. So let's transition to the next session. Now, this is a Developer Days conference. You know, even though this is the operations track, it is Developer Days. So while, you know, Paola showed a lot of cool, you know, user interfaces and maps, many times our customers want to use APIs for interacting with the controller. So Nicola Martino is the next presenter, and he's a senior technical marketing engineer. He also came from the Pirelli acquisition, so I guess you know, we got some pretty smart people over there in Italy. You know, and one important point, and I think we kind of alluded to it in the previous session, is that Cisco started with a controller approach with CNC. And services, VPN services, segment routing, traffic engineering services, bandwidth management, you know, all of those cool things. And we've talked in the past about those. And now, you know, over the last couple of releases, we focused more on element management. And Nicola is going to talk about how, you know, the APIs can be used for accessing the element management functions. So, Nicola, thank you, and the floor is yours.
Thank you, John. Let me start sharing. Okay. So, welcome everybody. My name is Nicola Martino, and today I will give you an introduction session on a new set of APIs that are made available for Crosswork Network Controller that focus on element management functions. Okay, let me represent this slide again. So Paolo already presented this slide, so let me start the conversation reminding you what the element management functions are, as also John mentioned. So we started with just the SDN controller for IP network, and then we added on top new capabilities that focus on element management functions. So this component in Crosswork Network Controller delivers inventory, fault, device upgrades, and performance management counter collection. As you can imagine, all those capabilities are made available through the Crosswork Network Controller graphical user interface, but also through the APIs. And this is the topic of today's session. Those are the areas that are covered by the API. So we have a large set of APIs for inventory, for alarms. We have different types of notifications. So we have RESTconf-based notifications, but we also have the possibility to integrate with a Kafka messaging bus and their stream inventory or alarm notification on Kafka topics. We also have device level counters collected and made available in different ways. And we also support device software upgrades. Now, for time constraints, I cannot cover all areas, but I will focus mainly on inventory and alarms, covering also the notifications, RESTconf notification option. Okay. Now, if you look at the DevNet page, there we have all these APIs already documented with different section for the different functional area, with those all API calls described with the resource endpoint, the method, the filter, the supported encoding, and also the attributes. Now you may wonder, so why do I need with session? So it's already everything is already documented on DevNet. So why I need this session? So when people get to the DevNet page, then they start asking themselves, so, okay, cool, I have a lot of API describe, but how can I really use those API? What are the typical use case? I want real examples. And sometimes people come to me and say, you know what, I start testing those API, but I don't understand the output. So the target for this session is really going through use cases, giving you examples, use cases, and also giving you some details that are not yet available on DevNet. So this is really the target for this session, giving you practical example on how to best leverage those APIs. Okay, and this is where I said that in this session we also have additional information that are not available on DevNet yet. So let me start with the concept of fully distinguished name. So basically, the FDN of fully distinguished name is a unique is the unique identifier for every inventory object in the system, and it's the typical output you get when you query those APIs, and can also be used as a filter option on some of those API calls. So the FDN, it's a string, and it's typically made of a sequence of type and value, where the type is fixed, and you see here the values, while the value is a sequence of attribute and value. But the next slide will clarify the concept better, because maybe it was too complicated. So let me give you some examples. So those are some FDNs. So we have FDN for nodes, equipment, physical connect, dimension point, and so on. And as you can see from the example, it's a sequence of type and value. So we start with, for example, for the node, we have Cisco MS as type ND, and then the ND or node type is followed by the device name. And as you can see for the other examples, they all start with the same two types, ND and D, and then followed by the either the equipment type or the termination point type with their own attributes. And the attributes can be concatenated, as you can see, for example, for the interfaces, where we also have the layer rate. It is very important. Using the filters, so when you run the query API, so the response can be large. So there can be multiple objects returned by the API. So what if you want to filter to just the entities that you are interested, rather than the whole set of objects, and also if you want to reduce the workload on the system. So we have filters, we have system filters, and we also have on a per API based filter. Those are in the form of parameter equal value, and you can concatenate filters by using the ampersand character. Now, two important filters that are not described on DevNet are the start index and max count. So when you query the API, the output is coming back with the batch size of 100. That means that if you have more than 100 elements to be returned, you need to do some paging. So the start index is exactly what is meant to do. So you can do paging on a 100 base, but we have a more clear example coming up in the next slides. The other one is the max count. So as you can imagine from the name, the max count reduce the result output to X number of entities or instances. And what I usually do is I use max count equals 0 to test the API behavior and to see the typical output. Now, this is an example of a get where in the either section of the output, you have first index and last index, and you see last index is 99. That means that most probably you have other objects returned by this API, and you need to do some paging. Now, appending to the URL start index equal 100 or 200 the other and so on, as we have in the top right part of the picture. This way you can start paging, and only when you get the last index returning a value lower than 99 on 199 and so on, that means you have the full output returned by the API. Now, inventory data and alarms. So as we said, we will focus on inventory and alarms. There are a lot of APIs for each functional area. So I want to focus rather than exploring all possible API call. I want to only focus on the main API call and give you example and also example on to use them, and also example output, because those are the basics for the alarm inventory API usage. Then once you understand how this works, then you can start moving with others, like for example for the alarms we have other set of API that focus on the alarm life cycle, like acknowledge and acknowledge, clear, and so on. So but you first need to understand how those main API call can be used. Let me start with the non-inventory. As you can understand from this slide, this API is meant to return attributes like node name, IP address, and so on. The most important is the equipment list attribute. This returns a list of inventory objects in a hierarchical way, but we will explore this in a few slides. So here we have a list of filters that you can use. In the example we have on the bottom side of this slide, we have the API, the endpoint, with also the filter highlighted in orange. Let me focus on the other two examples because we will cover the first one in a couple of slides. So the first example is where you focus on a single device and you want to return all inventory for that device. And the next example, the last one in this page, retrieves all inventory for all platforms of a given type. So those are the typical use cases for this API call. This is an example output where we see a long list of attributes like the device name, the device platform. As you can see here, we have the FDN in the center of this output. Then we have a software version and so on. All those attributes, by the way, just to remind you, are described in on the DevNet page. This is where we mentioned the equipment list attribute. As we said, this is a list, and when you expand the list, you get access to the full inventory list. And as you can see, and as we mentioned before, all those objects are referenced by their FDN. So it's important you get used to this term and how to read those strings. Now, as we mentioned before, the output also provides the device containment in a hierarchical way. What does it mean? So the discovery process leverages the entity map for discovering the physical asset, and typically every object in the inventory list has a referent index that points to its parent and provide a list of lists. So in the same way, when you look at the API output and the inventory list, every object in this inventory list, of course expressed with their own FDN, has a referent index to its parent, so the contained equipment, and parent the contained equipment, and also pointed to the list of containing equipments, also in this case expressed in form of FDN. But next slide will clarify with an example. So here we have the equipment list. As you can see from the example, the second object from the list is rec 0, and it has a couple of attributes, containing equipment and containing equipment. The containing equipment is the parent of this object, while the containing equipment is the list of leaves. In this case, is only pointing to a single element in the output. And as you can see, the first object returned by this list is indeed the parent of the rec0 root processor object. Yeah, we mentioned about a filter that I've been mentioning before, but in this example will be more clear. So as we said, this API can be used to retrieve the device inventory list, but you might be only interested to retrieve from the network just basic information like device name, IP address, software version, and so on. So you might be not interested on the whole physical inventory. So there is this filter that is only available for this resource endpoint, where you can completely filter out the inventory list and only focus on the basic attribute. This will help a lot on alleviating the workload of the system when querying through this API. Now, locate equipment. So the previous API call, the typical use case is starting from a node or a product family, retrieving all the inventory for that node and so on. This API call, the typical use case, is working on the other way around. So starting from a given equipment object, retrieving from the network where that object is. So it can be used as a search engine. Also, in this case, we have the list of available filters and examples. So the first example is retrieving all 10 gig interfaces. This might be more or less useful depending on use case. The next example is retrieving all SFPs of a given matching given product ID. And again, this will be the next example. Or you can filter by the description where you look for a specific, I don't know, for example, root processor card in the entire network. Now, let me give you the example for retrieving based on a product ID. So this is the output where you see inventory informations like the product ID, the serial number, where this pluggable is located, again, in terms of FDN and so on. Termination points. This returns all, let's say, ports. Let's be clear, ports. Of course, we comply with the TMF standard, so that's why you see those the ports reported with those with this naming convention. So we have a physical termination point, floating termination point, and connection termination point. Where the physical termination point, to give an example, those are the at least in CNC, those are the optics controller returned by colored or gray optics. The floating termination point, those are logical termination points. And to give you an example, those might be, of course, the Ethernet interfaces. In those cases, those will be termination point anchored to a card, but there will be other termination point that will be not anchored to card. For example, loopbacks, those will also be reported by floating termination points. And finally, connection termination points. Those are a subset of the floating termination points, basically termination points that are used to terminate, for example, IP link or optical link. But I will give an example in a couple of slides. Also, in this case, we have the available filters and also examples. You can filter by all floating termination points, or you may filter by all termination points available on a given node, or like the next slide example, filtering on all 10 gig interface available on a given node by adding the layer rate. as you can see from the last line from this slide. And this is an example of some, maybe one example that I forgot to mention. You can also pass as a filter the termination point FDN. So this can be useful if you are not listening for notifications, because if you want to have your tool that connects to the API always updated, you either listen for the notification, or if you don't want to listen for the notification and you want to have an updated information on a given object, you can pass straight the object FDN as filter option. So, and as for the previous example, here we have all attributes for the termination points, like the internet name, the description, speed, and so on. As you can see from the example, one of the attributes is the IP address. That means in this case, this output is listing this port as a floating termination point. But if you filter by connection termination point, this port will also be listed as in that list. So basically, the connection termination point is a subset of the floating termination point. Retrieving alarms, so you can retrieve active and cleared alarms. So by default, you get all alarms returned by this API. So if you want to focus and returning both system alarms and also device alarms, if you want to filter just device alarms, you need to apply this filter reported with in green, so alarm type device, and then you can add the typical filters like adding the node name or an FDN or a termination point with the delay rate, or simply the severity without any other filter. So that to retrieve just the active alarm. So again, remember that by default you also get the cleared alarms. This is an example where you have the description, the attributes like the description, severity, the different timestamps, and also in this case we have an FDN. Remember that the FDN relates to inventory objects, so you don't have FDN for other things, like there is no FDN for an alarm. Notifications, we have two different types of notifications. We have connectionless and collection-oriented notifications. When you use collection-oriented notification, you can pass filters through the URL, filters for example, for the objects and so on. While for the connection-oriented, for the connectionless, whatever is required for the retrieve of for the subscription is passed through the post payload. And this is the list of resource endpoint. We have 4 for connection-oriented, 2 per topic, so 2 per alarm and 2 per inventory, and and 2 different basically depending on the encoding. While for the connectionless, we just have 1 resource endpoint. Here we have an example of a filter format for the connection-oriented. When you subscribe using a connection-oriented, the connection-oriented option, the connection is kept on, and the system will stream inventory and or alarms notifications until the client disconnects. And by the way, we have a keep alive airbit that check for the connectivity every 60 seconds. On the other hand, when you do connectionless notifications, the session is kept on, and the system will stream notification until a specific delete command has been issued. So there is a list of, let's say, life cycle commands for the connection subscription. So where you can monitor, you can delete, and so on. And here we have an example of filters for the connectionless subscription. So here we have an example of filters for both connection-oriented and connectionless. Bear in mind that for the subscriptions, we have filters based on product family, product type, severity, and device unique identifiers. This is a complete example for the post payload, where we have the client IP address where we need to stream the data. We have the topic, in this case is alarm, but can be inventory. We have the encapsulation, and followed by the list of filters. Here we have a couple of notification examples. We have to mention here as you can see, the topic is inventory and the operation is create. So that means that this specific object has been just inserted on a device, and all attributes are more or less the same as you will get from the query API. This is an example for the alarm notification. In this case, the topic is alarm and the operation is modified. That means this alarm was already present in the system and it got updated by this event. Last slide for this session, and I'm perfect on time. Last slide of this session. So we have testing client that you can use to test connectionless and connection-oriented notification. Those are available on GitHub, and we have different binary for the different software versions. And with this, I conclude my session. Back to you, John.
Thank you, Nicola. That was terrific. I mean, this is a developer conference, and you provided a lot of excellent information on how the system can be used to abstract and provide, these APIs for element management. And what's exciting is, it is a multi-vendor capable product. So, we can really see how this could be used
Absolutely.
by operators. So I do have a couple questions, and definitely we have some developers on the line. So what happens when an API call does not have any data to return, or there's no match with a used filter?
Okay, good question. So you might remember we have part of, the output contains an header. So that header contains first index and last index. When there is no matching filter, or there is no data at all to be returned by the API, in that case, the last index will return -1. So by convention, that will be typically an integer, but when it returns, you can basically implement a check. If the last index is -1, that means there is no data to be returned by that API.
Okay. Can I filter alarm notifications for a specific alarm type?
For a specific alarm type, no. Unfortunately, there is no subscription per alarm type. You only can filter by severity. So you have to filter by severity or by one of the other filters that I've been showing before. And then if you want to put additional filters, that logic needs to be implemented on the client side. So we need to put the filter on the client itself, at least today. So we might implement additional filters in the future, but those are the list of filters available today.
Okay. Yeah. So if that requirement is important, for the customer that asked the question, please let us know.
Talk to Paola.
We'll prioritize it.
Do you have a delete? We'll give Paolo email address.
Yeah, Paolo. Do you have a delete operation for the RESTconf notification?
Sorry, can you come back?
do you have a delete operation for these
delete
RESTConf
operation.
notifications?
Delete operation, not today. We are coming up because, for example, if you think about alarms, so there is no really a delete operation for alarms because you typically get updates. So the alarm can raise, clear, and then raise again. So there is no a delete operation for alarm. But we notice there is a need for the delete operation for inventory that is coming in 7.1 or one of the upcoming releases. Thank you for the question,
great.
John.
Yeah. And I think we're a couple minutes ahead of schedule, but I think one important point, Nicola, for folks that may not have understood this, is that the Crosswork Network Controller comes in, an essentials package and a advantage package, and the advantage package, has a lot of traffic engineering, service provisioning, and other things, where the essentials is more around these element management functions. So I guess, what you presented here is really some of the things that are part of the essentials package. So if a customer only wanted the element management API functionality, they can just purchase this package for that. What you showed here today, is that correct?
Correct. So the essential package is the first and basic package that you can install on top of the Crosswork Network Control infrastructure. There you have the advantage that delivers the use cases you mentioned before. But bear in mind that before you can install the advantage package, you must install the essential package first. So that basically translates every time you leverage or you want to leverage the features that more focus on the IP domain controller side of the product. In any case, those element management capabilities will be there anyway. So the advantage does not prevent the customer to also leverage the essential, in short.
Okay, perfect. Well, thank you again, Nicola. Cool stuff. And now let's jump to our next presenter, Julia Palomino, technical marketing engineer in the service provider network automation team. And Julia, thank you for doing this. And again, in the spirit of a developer conference, you're now going to talk about some of the APIs that are available from the Crosswork planning product, which really, would provide, simulations and ways that the customers can plan their bandwidth usage and when they need, to upgrade links and all of these sorts of things. And obviously with APIs now, this can become much more automated and extensible for different use cases. So thank you, and please go ahead.
Okay, thank you, John. Hi, everyone, and thank you very much for your valuable time to attend this session. The main objective of this session is that you will learn how you can supercharge your network planning leveraging Crosswork Planning APIs. So what are the outcomes for you after this session? You will be able to describe Crosswork Planning key functionalities. You will learn, you will have a good idea how you can automate network planning tasks using the Crosswork Planning APIs. And also you will be able to describe and know how to use the Crosswork Planning SDK. So first off, I would like to start with a couple of poll questions. So please share with us, what tools do you use today to do network planning? Please, you can select one of the responses that I think should be displayed in the screen. So John, I think we can give maybe 15 seconds, 20 seconds.
Okay. Do I see the poll somewhere, or I don't? We'll.
Is it not displayed on the event? No?
No, I don't have access to that.
Okay. Well, so in any case, even if you don't do network planning, or if you use a manually way to do a network planning, maybe using some Excel spreadsheets, or if you do partially automate your network planning, maybe using some scripting. So after this session, you will be very interested in adopting crossword planning for doing network planning, because you will see how you can easily automate and simplify your network planning. So next, I will start doing a quick overview of what crossword planning is. So I'm sure throughout yesterday and today sessions, you learned a lot about crossword automation portfolio that is very focused on automating the complete life cycle of the network operations. So recently we introduced crossword planning as part of the portfolio and placed the leading role in the planning part of the network operations life cycle. We want to build capacity where traffic will be in the foreseeable future using insights of customer traffic patterns to project where and when to acquire these capacities. We want to avoid the scenario of overbuilding capacity, which leads to inefficient resource use. And at the same time, we want to avoid failure scenarios on traffic growth, which leads to congestion and degraded customer experience. So in summary, crossword planning is an AI-enabled network automation tool designed to empower network operators to simplify network planning, to optimize performance, and to achieve operational excellence with speed, accuracy, and precision. So next, what are the key features when we talk about crossword planning? First, we talk about predictive AI techniques that provide a crystal ball into the future. So for example, if an NSP fails along its original path, how would it be rerouted? So crossword planning will visually represent the protected and rerouted paths and whether the reroute would cause congestion or not. And then we have modeling, simulations, and forecasting tools, such as, for example, the simulation analysis that is also known as the worst case analysis tool that will simulate failure scenarios across the entire network. And using this simulation analysis tool, we can automate the failure at every circuit or node or SLRT in sequence and provide a detailed report on the impact on the network. This tool will also provide a worst case traffic view in response to those failure scenarios. And then we also have the optimization tools that will analyze traffic flows network-wide and recommend suggestions such as routing metric updates or LSP reroutes. And these tools will also provide detailed reports and visual representation on how the network will operate under these changes. So next, when we talk about network planning, one important topic is the network modeling. If we want to do a proper network planning, we need to have a proper network model and that will faithfully represent the actual network. So network modeling becomes the basis and the solid foundation for IOs. So in crossword planning, we have two methods to build a network model. First one is using an active collection with a crossword planning collector that will gather data directly from the network using built-in collectors that will collect different pieces of information from the network and then consolidate into an aggregated and abstracted network model that is also known as plan file. The key is to abstract the model as much as possible. For example, a network model could comprise links, nodes, LSPs, traffic demands, and their attributes. And every model is different and is made up of different elements and attributes as required to support specific use cases. And some of these attributes are collected directly from the network, while others are derived from the simulation engine. And then we have the second method, that is to build the network model offline. And for that, crossword planning provides built-in tools and also provides its powerful APIs. So we need to remember crossword planning network model is extensive, is extensible, is multi-vendor, and allows for both fidelity and flexibility. So that being said, I would like to show a quick demonstration with few of the common use cases using crossword planning. So in this case, we access to the common web UI. From there, we can access to the network design application from where we can visualize the network model. For example, we can select a traffic demand and crossword planning will represent the routed path. So I will start with the first scenario, that is to execute a simulated single failure. So I will select one specific interface and then we'll select to do a simulated failure. Once the failure is executed, crossword planning will represent the rerouted path for the demand that I previously selected. For the second scenario, I will use the built-in capacity planning optimization tool. I will set the maximum interface utilization to 75%. And then I will select to minimize the capacity as optimization objective. Then I will set to create a new model after the tool is executed. And after execution is completed, it will produce a detailed report showing the list of circuits in the network that require some upgrade. Also, it will show the representation of the network, how it will operate after these changes, after capacity is added. So for the next scenario, I will use another built-in tool that is the metric optimization. I will select to minimize all the interfaces utilization and then set to produce a new network model after the execution of the tool. So after execution is completed, again, it produces a detailed report showing the recommended suggestions, in this case, the routing metrics that needs to be updated in order to optimize the interface traffic utilization. So with that, we can clearly see how crossword planning can automate and simplify my network planning. But we don't need to stop there. We can go even further and supercharge our network planning using crossword planning APIs. And why we need to extend network planning use cases using APIs? We may need to augment the network model. As we said, every model is different and is composed of different elements and different attributes. So using the APIs, we can access the model and add, edit, or extend new elements and new attributes. We may need also to automate the entire network planning workflow. So using the APIs, we can access to every built-in simulation tool in crossword planning and customize our workflows. So then using the APIs, we can not only access to the model and to the attributes that were collected directly from the network, but we can also access to the attributes that were derived, that were generated by the simulation engine, and hence access to the simulated results and then do some post-processing based on our needs. And then, of course, we can also use the APIs to integrate crossword planning with external tools. So next, some good news is that crossword planning offers, for example, this optimization prediction module, also known as the OPM API, that its main characteristic is that it is it uses a high-level Pythonic syntax. So for example, in the pictures below, we can see to the left side how an operator can add manually an LSP using through the crossword planning API. So he will need to insert the new LSP and set the corresponding attributes. But what if we need to add multiple LSPs, 100 or 1,000 of LSPs? We will need to automate this task, right? So to do so, we can use crossword planning APIs. So in the right side, you can see a code snippet of a Python script where we are using our OPM APIs. So the first important thing is that we need to import the OPM library. So in this case, we use the com.cisco.way.opm. And from the same line, we can also import the openPlan function. So this openPlan function we will use later in order to read the plan file and then set the content into a variable, for example, network. And from that point, we can start accessing the different objects using the dot notation and with any other Python library. So for example, if we want to access the model object, we can use network.model. And then if we want to access the LSPs object, we can use model.lsps. And then if we want to add a new entry into the LSPs object, we can use the append function, similar as with any other Python standard list. So in that case, we will need to pass the respective attributes of the new LSP using the append function. So this looks very simple, very easy to use, very high level Pythonic, right? And so then another characteristic of this OPM API is that it is a design RPC API wrapper. And I will explain what this means in the next slide. So next, we have also the crossword planning design API that is also known as the design RPC API. So what are the main characteristics of this API? It requires a client-server connection. It uses an RPC mechanism. Supported languages are Java and Python. And the main concepts that we need to take into account when we use this API to create our scripts is that we will use objects, attributes, and managers. So in the right side, we have a snippet code of a Python script using this RPC API. The first main important step that we need to take into account is that we need to import the design library, that in this case is com.cisco.way.design. Then a good practice is that we also import the respective classes and data types that we will use with this API in my Python script. Next, second important point is that we need to establish the connection, and we do so using the service connection manager. Then once the connection is already established, we can access and read the plan file using the plan manager. So after this point, we can start accessing the different objects by calling the respective managers. So for example, if I want to access the traffic level object, I will need to call the traffic level manager. Or if I want to access the QA object, I will need to call the QA manager, and so on. So then in the snippet below, we have a function that will do the insert of the LSPs into the model. So what we need to do is to create an LSP record for every new LSP that we will insert. And this LSP record is a class structure, and it is composed of all the attributes that belong to the LSP object. So at some point, we will need to access to the LSP's object, and we do so by calling the LSP manager. And if we want to enter some specific traffic into my new LSP, I will need to call the measure traffic manager, and later use that measure traffic manager to access the LSP measure traffic, and so on. So this is like a hierarchical level that we need to call the respective managers in order to access the corresponding objects and attributes. So at first sight, you may think that this is a bit more complex than the OPM API. And of course, we require more lines if we compare lines of code if we compare to the OPM APIs for the same or similar operation, right? But one main important point when we talk about the design API is that this is the very native cross-planning API. So this means that with this API, we can access to every attribute in the model, either if it is a measure or derived or user-defined. It can access to every table in the reports and also to every built-in simulation tool in cross-planning. And this is something that is not necessarily available with the OPM API because the OPM is actually a wrapper of this API. But the good news is that both APIs can interact with each other. So in the OPM API, we have some specific functions in order to call the corresponding RPC API, or we can simply import the both libraries into the same Python script and then combine the usage of both. So then we have the cross-planning job manager. The job manager is a page in the cross-planning UI that will let us visualize the tools and initializers that were scheduled to run as background jobs. In these background jobs, we can set priority, schedule time, or we can cancel them before they enter into the running state. So then one important point is that this job manager page will also provide options to execute jobs using the CLI binary tools that is not in the scope of this session, and also using the custom scripts, which is the main focus of this session. So next, I will show an example of a demonstration using the OPM API for a very basic use case that is assigning sites to nodes. So in this case, we can see in the plot how the nodes are grouped, and then we can verify the sites table that it is empty. Then we can check the format of the node names, and we can see that the first part of the name represents the function of the router in the network, and the second part represents the acronym of the city where it belongs. So we can go ahead and manually insert a site via the UI. We can set the name using the second part of the name, in this case ATL, and set manually the geographic location using the city name, in this case Atlanta. Once we click save, the site is created. We can see in the plot, but it initially will have 0 nodes assigned to it. So we can go into the nodes table and select all the nodes that belong to this ATL Atlanta site, edit them, and assign the corresponding site to them. So once we click save, we can see the site is updated and it is showing the 3 nodes belong to it. Next, cross-planning offers one built-in tool to do similar operation, but in an automated way. So we can select all nodes, we can define some rules, for example, set what delimiter we will use in the node name, in this case the dot, And we can select which part of the name we want to select and use as the site name. Or we can use maybe some regex expressions. But we can also automate these actions using our cross-planning APIs. For example, the OPM API, we need to import the library called the OPM open plan function. Then we read the CLI arguments, our input plan file, output plan file. And then using the open plan function, we will read our input plan file and set into the network variable. Then we start using the dot notation to access the different objects, model and nodes. Then we can use a for loop in order to read every node in our nodes object and then verify if the node belongs to a site or not. And if it doesn't belong to a site, then we can read the node name, split using the dot delimiter, and then select the second part of the node to use as the site name. And then with that single line, we can create a site and assign the corresponding node into the site. And finally, write the updated model into my output plan file. So then let's go to the cross-planning UI and the job manager page. From here, we can select to add a new job using a script. We can either upload a new script or use an existing script. In this case, I previously uploaded my script. So next, we need to select the input files. In this case, I will select my input plan file, that is the unprocessed lab.plm. And next, we need to set the script command. In this case, we need to call the script and then pass the corresponding CLI arguments, the input plan file and my output plan file name that will be plansites.plm. So then click next. We can select to execute the job now or in a background scheduled job and then set the priority. And once I click submit, the job will be created. We can click refresh and then it will be in running state. And then once it is completed, it will produce an output file containing my output plan file. So next step is that I need to import my output plan file. Once it is imported, I can click on it and then it will be loaded into the network design page. So here we can verify that all the sites are already created, nodes are grouped into sites, my site table is populated, and then we can combine with another built-in tool, for example, the assign locations to site, that will read all the names of the site and will do a best match based on the name to assign the corresponding geographic location. So we can see now geographic locations are already added, and if we change to the geographic view, we can visualize the position of every site in the map. So then I have another example, and this time it's a demonstration using the RPC API, and my use case will be that I will insert demands in bulk. So here I have my network model, which already has the demands table populated. All my demands are functional. If I select one of them, we can see cross-planning represent the routed path for each. So next, we have the option to insert new demands either individually or using demand mesh. If I use demand mesh, I will need to pass the list of source and destination nodes. And later, I would need to use the demand deduction in order to assign the corresponding demand traffic. So for this example, I will select to add a new demand individually. So I need to set the mandatory parameters as the demand name. And then I will select the source node that in this case will be node 4. And the destination node that in this case will be node 5. So then I can select to add some demand traffic, in this case 6 megs. So once I click save, the demand will be created. And then we can verify in the demands table the new demand is added. We can open the name column and verify the corresponding name that we set for this specific demand. So it is totally functional. We can see the links and color links are updated because traffic increased because I added my new demand traffic. So we can automate all these operations also through the APIs. So for example, I have this specific CSV containing 4 demands, right? So I have my Python script that will use my RPC API. So I need to import my design library. So then I will import also the classes and data types that I will use in this script. And next, let's focus on the main function. So in this main function, I will start reading my input arguments, in this case, input plan file, output plan file name, and then the CSV file that will contain my demands. So first main step is that we need to establish the connection, right, to the design API service. After connection is established, we can read the plan file using the plan manager. And then in this case, I will read every entry in my CSV file that will contain every demand attributes, and I will create a dictionary for each demand. And then we'll call the update demands function. So in this update demand function, I will basically access the demand object by using the demand manager. And then I will access the demand traffic object by using the demand traffic manager. So then I need to create a new demand record for every new demand. The demand record is a class structure containing all the attributes of the demand object. Next, I use the demand object in order to insert the new demand records. And we do the same for the traffic using the demand traffic manager. So after all this process is completed for all the demands in the CSV file, so next step is that I will write the updated model into my output plan file. And finally, we close the connection to the design API service. So now let's go back to the cross-site planning UI in the job manager page. So I will select to add a new job using a script. I will select my script that is already uploaded. And we'll select next, and next I need to select my input files. In this case, the input plan file, that is the srset.pln. And also I will select my CSV file containing my demands. So next I need to set the script command that is calling the script and also passing the corresponding arguments, input plan file, output plan file, and then the CSV file containing the demands. So next, I will execute the job now and set the corresponding priority. And finally, once I click submit, the job is created. So when I click refresh, we can see it is in running state. And once completed, it will produce the output plan file. So next step is to import the output plan file and then load into the network design application in order to visualize the results. So once I open the plan file, then I can go to the demands table in order to verify the new demand. We have our 4 new demands that were inserted via APIs, and they are all functional. If we select them, we can see cross-site planning will represent the corresponding routed path for each. So next, I would like to show to you another example that is an integration demonstration between CNC and cross-site planning. So as you may know, CNC collects the topology in real time, and it will also have traffic statistics. So we can take advantage of that and take a snapshot of that topology and then export it and then import it into cross-site planning in order to use our simulation tools. So in this case, we have the CNC UI where we know that topology is collected in real time and traffic statistics are collected in a cadence basis. And then in the right side, we have the traffic engineering panel where we can see that we have, for example, in this case, 32 SRMPLS policies. And then we have also 9 SRV6 policies and also 2 RSVPT tunnels. So in total, we have 43 LSPs in this network model. CNC offers some RESTconf APIs in order to do the export of this network model into the plan file format. So next, I have my Python script using the RPC API and other standard Python libraries. So let's focus on the main function. The objective of this function is that it will call other functions that will do the export of the network model from CNC, and also will do some post-processing of the model using a specific template file. So I will start reading my input arguments, like the input plan file, output plan file will provide the CNC details, and also the template file name. So then I need to start, of course, opening the connection to the service design API. And then I will set the corresponding authentication with the CNC. And then I will call to my getCOE function that will do the export of the network model. So once the network model is exported, then I will read the plan file using the plan manager. And next, I will start the post-processing of the model. So for example, if copy template is set to true, then I will call the copy from template function that will basically get all the geographic location from the template file and set into my model. And then if copy inventory is set to true, I will also call the copy from inventory function in order to copy from the layout file, from the template file, some basic inventory details like vendor, model, and OS. And then if create demands is set to true, then I will use via API, I will call the built-in simulation tools like demand mesh and demand deduction in order to create a full demand matrix and also assign the corresponding demand traffic. So once this is all done, next step is to write into the output plan file the updated model And finally, close the connection with the design API service. So next, let's go back to our cluster planning UI in the job manager page. So I will add a new job, then select the corresponding script. And next, select my input files. In this case, I will select my input plan file. That will be an empty plan file. And then select the template file that I will use for the post-processing of the model. So next, I set the command and add the job. Then I check that the job is running once I click refresh. And once completed, it will produce the output plan file. So next, we can go ahead and import the output plan file, and then we will visualize that it has exactly the same topology with the geographic location as we had in CNC. We can verify in the nodes table the 8 nodes were imported, and we have some basic inventory information. And then if we check the LSPs table, we can see that we have the 43 LSPs that were imported, including the SRv6 policy, RCVPT tunnels, and also SRv4 policies. And then in the demands table, it is already populated and all demands are functional. If I select one of them, we can see cross planning will represent the routed path for each. So now, so far, we have seen how we can build the scripts using the design and OPM APIs and execute them locally in the cross planning VM through the job manager page. But what if I require to execute, to automate some tasks and execute a script remotely? So for that, Cross Planning offers the Cross Planning SDK. The SDK is a package containing the design and OPM API libraries and will allow the user to write and execute scripts using design and OPM API outside of the Cross Planning VM in a Linux user machine that will have some specific Python requirements and will connect to the design API service that is running locally in the Cross Planning VM. And for communication between server and clients, we will use a TLS secure protocol, and also we will use SSL certificates. So next, I would like to show another example of a demonstration using the SDK client. And for this use case, I will also execute the inbuilt simulation analysis tool using the APIs. So in this case, I will use my US1 sample plan file that already contains a sample network model, and I will show you how you can execute the simulation analysis tool from the UI. The objective of this simulation analysis tool is that it will execute automated failures across the entire network based on the failure sets that I select. In this case, I will select nodes and circuits. So next, I will select to execute the tool now, and once the execution is completed, it will provide a detailed report. In this report, we can see in the summary tab, it provides the summary of the QoS violations and their failure conditions. And then in the max utilization tab, it will provide the percentage of failure in this network, in this case, 23%, that would cause the maximum utilization to exceed 100%. So then I close the report and go back to the model, and we can see that the tool also created a worst case traffic view showing the maximum utilization, worst case utilization for every interface in the model in response to the failures that were executed. Then in the interfaces table, it will also populate the worst case column. So for example, we can sort from highest to lower the worst case utilization, and we can find out what would be the maximum interface utilization in this network, that in this case, it is 125%. Then we can open also the worst case traffic and do some similar action. We can sort from highest to lower, and then we can find out what would be the maximum worst case interface traffic in this network, that in this case, it is 3 gigs. So we can automate all these steps using APIs with this Python script using RPC API. So I will focus in the main function. Again, I will read my input arguments, like the input plan file, the failure types that I will pass to my simulation analysis tool, and the cross planning details, like IP address, port, and protocol that is fixed to SSL. So next, I need to open the connection with the design API service, and then read the plan file using the plan manager. Then I need to access the tool object using the tool manager, and then we'll create a simulation analysis using the tool manager. So next, I need to set the options that I will pass to my simulation analysis tool, in this case, the failure types that I receive via CLI argument. And next, I will need to execute my simulation analysis tool. So next, I will call two functions. In this case, the first one is to get the maximum interface worst case utilization, and second one is to get the maximum interface worst case traffic. And finally, we'll close the connection. So next, I will show you my SDK client. In this case, this is already prepared with all the prerequisites of the Python libraries, and the SSL certificates are installed. So in this case, I have a specific directory structure where in the scripts, I have all my Python scripts, and in the plan files, I will have my input and output plan files. So I will call my script using the Python command, and then I will pass the corresponding arguments: the input plan file, the IP address for the cross planning VM, the port where the design API service is running, and the failure types that I will pass to my simulation analysis tool, in this case, the nodes and circuits. So once I execute this script, it will run in the background the simulation analysis tool and provide exactly the information that I am looking for. In this case, the maximum worst case interface utilization, that is 125%, and the maximum worst case interface traffic, that is 3 gigs in this network. So this way we can see how we can remotely connect to the design API service and also remotely execute the scripts in a secure way using TLS protocol. And then also we can access to the simulated results and do some post-processing in order to get the specific information that I am looking for. So with that, I completed all the demonstrations for today. So I would like just to share some key takeaways. As you could see, you can simplify and automate your network design, planning, and optimization using cross-site planning. But you cannot stop there. You can go further. You can supercharge your network planning using cross-site planning APIs. And using cross-site planning API for customization is really easy with the Pythonic APIs. So one call to action, remember tomorrow we will have a hands-on lab session for introduction to cross-site planning, where we will explore some basic use cases. And also we will have few scenarios using APIs. And then I wanted to share these reference links with a cross-site planning information center. Also in T-Cloud, we have an available lab that is the cross-site planning 7.0 design. And I'm sharing also the link for the cross-site planning DevNet Center. This is currently under QA review, but will be available very soon. And I'm also sharing a GitHub repository, this is public, where you can find some sample scripts, including the ones that I showed in this session and a few others. With that, I completed my presentation. So thank you very much. And back to you, John.
Thank you, Julia. Nice job. We only have 2 minutes before we go on break. First of all, I figured out how to look at the survey results. So let me just tell you guys what the responses were. So the first one was, what tools do you use to do network planning? Interestingly, most of the folks, almost 43%, use Excel spreadsheets.
Okay.
15% do no network planning. 15% use scripting, and 30% actually do use in-house or vendor automation products. So
this is really interesting.
That's pretty interesting that 43% are using Excel spreadsheets. So over 50% are basically doing it or not doing it with on paper. And then the other survey, how familiar are you with Cisco WAN automation engine or cross-site planning? And 75% never heard of them,
Okay.
which is a big opportunity, I think, for both the customer and for Cisco.
Yes, I think it is the right audience, because you will be interested in adopting some automation tool for your network planning.
Yeah, and the interesting thing about when Javier spoke about AI and getting into proactive use cases, the real nirvana is where your AI tools can begin to move traffic across different paths, so you can basically optimize your bandwidth and provide the best user experience. And these tools are really the back end systems that the AI will use to kind of figure out the best paths to take for things like bandwidth on demand and congestion management. So it's important that folks begin to really learn about these tools, because this is how it's done, really, to really make sure that bandwidth is used as efficient as possible. The last poll, on a scale of 1 to 5, how confident you are in programming in Python. 33% not confident at all, 33% a little confident, 17 fairly confident, and 15 extremely confident. So the majority of the audience, aren't that confident with Python tools. And I just want to highlight that you showed Python and APIs, since this is a developer conference, but certainly there are front end UIs and other menu driven tools for the product that weren't really shown or highlighted as much. So you're not you don't have to know Python to use these tools, but certainly if you're a developer, you can certainly maximize it.
Correct.
So with that, I don't want to hold up the break. So we're going to come back here at the bottom of the hour. That's 10:30 New York Eastern time, or the bottom of the hour, whatever time zone you're in, and we'll start back up again. So go grab a cup of coffee. Don't forget to use the Q&A and the chat rooms for the rest of the session. And we'll see you back here in 8 minutes.
Thank you.
The Internet for the future has enormous opportunities that enable new experiences and participants with unlimited potential. And the service provider network will lead the way with a dynamic and programmable infrastructure that is managed with modernized operations. This requires a software platform using data-driven analytics to provision, adapt, and optimize in real time based on changing network conditions, and to visualize the infrastructure across a single pane of glass. Cisco Crosswork Network Controller delivers a turnkey closed-loop automation solution to address these demands across your multi-domain, multi-vendor, physical and virtual infrastructure. Innovation that will help you achieve 78% faster service deployment and 66% lower operational expense. Let's examine how to simplify operations on your trustworthy, programmable network infrastructure. Crosswork Data Gateway collects network data at scale on auto-discovered devices using industry standards based on BGP link state and PCEP. In Crosswork Network Controller, a unified dashboard provides visibility of your network, showing critical operational data such as product type, operational state, and software type and versions. Provisioning segment routing and traffic engineering policies is easy with the Network Controller. Define specific policies to serve as the foundation for all network services. In this example, a tunnel with a head end as node 5 and a tail end as node 4 is provisioned with a color and path. An explicit or dynamic path can be assigned based on customer needs. In dynamic, you can specify a metric type such as IGP, TE, and others. Let's choose latency. The route can be optimized using Path Computation Engine based on dynamically changing network metrics. Provisioning and managing L2 VPN or L3 VPN data services is fully integrated. Let's demonstrate with a L2 EVPN service, which can be created using REST APIs. Bind this L2 service to the newly created SRTE tunnel we optimized for latency. In seconds, the new service is created and ready for customer use. Using active topology, operators can visualize the route that was just created. With the newly defined policy between node 4 and 5, the path shown is based on the lowest latency, and a detailed summary provides additional data. Under segment routing, operators can examine finer details of the predefined policy that supports the L2 VPN or L3 VPN service. Network data is continuously collected and analyzed by optimization engine looking for network violations such as faults, high link utilization, and long delay that may impact customer experiences. Using these conditions, intelligently reroute traffic across the network using the segment routing policies based on interior gateway protocol, traffic engineering, or delay metrics. Crosswork Network Controller is the perfect solution to transform your operations in managing a dynamic network infrastructure. See immediate results through lowered operational costs and improved customer experiences that help you gain a competitive advantage. Automated, intelligent, simple. Today, we depend on networks to connect us. But that same network has experienced poor business outcomes driven by complexities from silo legacy technologies and manual operations. Communication service providers need a solution. Cisco delivers converged SDN transport to reimagine networks. We converged IP and optical layers so routers can natively connect with standardized pluggable coherent optics. Cisco Crosswork Hierarchical Controller empowers operations with speed to orchestrate services and automate assurance across a converged network. Immediately see improved economics to operate multi-layer, multi-vendor networks with 85% increased speed to deliver services and 62% savings in total cost of ownership. These results are achieved by unified visibility from the service layer to the underlying topology. By proactive insights using real-time and historical data to determine service health and optimize. And by prescriptive actions to provision services and automate assurance. Let's see Hierarchical Controller in action. Automatically discover your multi-layered network and visualize using a single intuitive user interface. The network inventory is pulled from multiple domain controllers to construct a consistent multi-vendor view. The blue line indicates an IP link, and the white line shows an optical link. Select a link to see the detailed path status, and then choose the path option to display details at each layer from service to the underlying fiber. When a failure occurs, elapsed time is the most critical factor. In this table, rapidly identify all links that have failed, including the type of resource causing a particular failure, and construct an inventory of all affected links. Zooming in on the OTS failure, we see 35 affected links caused by this single failure. An efficient root cause analysis can save tremendous time and resources to identify potential customer impacting issues. The network map displays the impacted L3 path and get more details. A click on the path will reveal all the layers impacted. By scrolling down, the root cause is revealed, which is the OTS failure between the two network nodes. Now, operations can fix this issue before any impacted customers notice. Within your dynamic multi-layer network, there is always potential to optimize customer experiences. We can choose from a range of optimization criteria that best matches your desired customer outcomes. Let's select latency optimization. Further, select the path type based on services and filter by service type. Or choose connections and filter by type, and in this case, we will choose LSP. We found 1,683 LSP connections, of which 73 can be optimized. Select the one with a 32% latency savings to see a comparison of the paths. We can reduce latency from 8.7 to 5.9 milliseconds to improve experiences of latency-sensitive applications. If the operations team chooses to act, the methods can be automated through the domain controllers. Crosswalk Hierarchical Controller is the perfect solution to improve the economics to operate your network. And through simplified operations of the multi-layer, multi-vendor infrastructure, your customers will gain a better experience. Automated, intelligent, simple.
Hello, welcome back to the operations track for our Developer Days session. Hopefully you had a good break there. We gave you a couple extra minutes because we were going a little long. The next speaker is Krishnan Thurukanda. I never can pronounce that right. Who's a principal technical marketing engineer. He's going to cover multi-vendor extensions and customizations for VPN services and visualization with Service Health. And I think this is an important point, is that, as part of the network controller, we have our network services orchestrator product, and the NSO product that's been been an industry-leading automation and provisioning product for more than 10 years. We've always been able to provision multi-vendor services. Well, what also we need to understand is how do we do visualization of a multi-vendor service? How do we do service health and assurance of a multi-vendor service? So Krishnan will go through some examples of that, and hopefully that's going to be helpful for you. So with that, Krishnan, why don't you kick it off?
Thank you, John. Thanks folks for listening in today. Just a quick question or comment that why are we even talking about extending CNC when why can't we have everything built into CNC, right? So the short answer for that is that any vendor that's trying to build a platform that's solving your problems, it'll be very hard for anyone to build anything that can do everything for everyone, right? I mean, it's just a simple statement here. What we want though is that we want a platform that does things for this particular space, the IP network services turn up and management. We want something that can be doing things good for, like, let's say, get you started with 80-90% of what you want, and does it, it's well tested and well qualified with a wide variety of Cisco products and latest and greatest technology innovations that are coming out. And then has a way of being extended to fit your needs, right? Because not everybody's needs the same. With automation, we want simplicity, but we also want to solve our business problems. Everybody has slightly different spin on it. And then we definitely want to have control over which vendor routers we're going to deploy in which areas. So multi-vendor is always important. Now, as John said, we've always had NSO to do the provisioning piece, but with CNC, we have added visualization, service health, and a lot of things. So let's go ahead and kind of review. In the last 2 days, meaning early today and yesterday, we actually had multiple presentation about Crosswalk Network Controller, both from the aspect of we have NSO, what does it, what do you get when you go up the stack with CNC. Yesterday we had Nelson, Deepak, and Sujay present some things. Early today, Paula talked about assurance, and Nicola covered a lot about what we can do with element management, right? But in short, you have CNC, which is this big gray box here that's talking to your routers, your IP MPLS routers, or in more and more, we are seeing IPv6 core-based routers running SRv6. And then you want to be able to interact with your network through a common API or common UI, right? That's what the black layer is your area where you're going to build your own software that will be driving your network through APIs rather than having you to be aware of every router's variations of CLI configs or operational elements such as mid paths and YANK paths. You want something to abstract it. That's where CNC comes in for the IP networks, right? And inside of it, we have a lot of things that we do, but starting from the top is basically service and transport provisioning. These are your VPNs, your traffic engineering based on the SRTE with MPLS or SRv6, or your legacy RSPTE. This is where we use NSO quite a bit, and basically this is going to turn up a service and do modifications, create update delete CRUD as we call it. But that's just day one, if you will, or day two when the service comes up. Your operations team, and this is why we are in the operations track here, is using CNC to manage the network, to keep it alive, to respond to customers, to be able to collaborate with among themselves to either make changes, to provide constant uptime, and basically be aware proactively of what the customer would be experiencing so that you can reduce any kind of outage times and have the experience high, right? That goes into the a number of things, but you started with visualization. If a network engineer can see the topology of a network and the service overlaid on it, that cuts down a lot of time in terms of a human to be able to absorb the information and to then take the next steps, right? And then when you go into traffic engineering, you're going setting up paths to very specific, with criteria. So is it even working as you expected? instead of logging into tens of routers to check, what is the next hop. You want to be able to nicely pictorially see it. So can you do all of that, right? That's the thing that CNC actually brings to the table. And then you have a series of things that are really needed for keeping the network working. Element management, network element, a router needs to be, deployed in the field. Zero touch provisioning helps cut down the number of effort to do that. Software and image management upgrades, all your FCAPS type of capabilities, fault alarms, performance indicators, and inventory. Nicola covered quite a bit about what all we are able to connect to the routers, get the live inventory and feed it to you, so that your business systems, your inventory tracking systems can use APIs and collect that. And this is live, meaning we are actually telling you what the router is telling us, right? Instead of you having to write code to go and get that info, we have it out of CNC. So that would be the element management features. When you get to traffic engineering, path calculation is a big thing, right? Some entity has to know all the network and the bandwidth patterns of usage, and then has to be able to respond to your intent-based, criteria to say pick certain paths that can actually satisfy your intent, right? So that engine is the path computation engine, and it has to be always up and always optimizing, meaning any path that it calculated and gave it to the head-end routers to inject traffic into that path. Network events happen, links go down, nodes go down. That original intent should be honored by constantly recalculating paths under those circumstances and keeping the original intent paths up, right? So this is always on running. For your services that are up, that are provisioned, that these are your customer-facing services, could be your L2 or L3 VPNs. For large SPs, there are quite a number of those. For large enterprises, there are a few of those. They don't change much. But at the end of the day, you do need to know that for what our client to deliver the transport service, what is the client experiencing? That means you have to constantly check the assurance of it. And you have also check maybe by sending some sample traffic, what the customer's traffic will experience. So you need all of that to be integrated in one controller to do that. And in the past, a lot of these things were done in silos. You would build separate tools. Every department with their own operations team would have its own siloed products, and your turnup service turnup may have a separate one. But with CNC, we're trying to do all of that in an integrated fashion. How does it do that, right? Again, you might have seen this slide in the last few presentations. But in short, you have the network at the bottom, the multi-vendor network devices, and we want to interact it using CNC. So inside of CNC, we have built a highly scalable microservices-driven architecture-based software, right? So this is basically using Kubernetes inside, but we ship it as a VM so that you don't have to worry about a lot of the Kubernetes-centric DevOps that would be needed. We have been asked in some cases to get to that level of interfacing with a pipeline that the customer you yourself will set up, and we give you the artifacts that you then integrate and test. But a predominant number of our customers are actually requesting some kind of abstraction where, keep it simple, give us an infrastructure as a service interface so that we deploy, on top of a simple VMware or AWS EC2 kind of infrastructure, or even KVM, right? So all of those are deployed, but the system itself brings up a lot of these nodes and then install the software, modular software. As you can see, there's provisioning module, visualization, optimization, service health, and so on. In terms of how we talk to the routers, which is where we need to be aware of multi-vendorness, right? We want to use standards-based protocols to talk to routers from point of view of getting the layer 3 topology and the path computation related conversation between the controller and the routers. We are using these protocols, the PCE protocol and the BGP link state. These are standards-based protocol. Most modern routers are supporting it. And this can be used for both your segment routing based MPLS, segment routing based traffic engineering, or even for RCPTE. And then in the CNC complex, these are actually implemented as XR based routers, because it's actually the ability to talk PSAP and BGPLS south to your routers is already built into XR. And so typically we recommend XR V9000s to be deployed, and we have integration on the top that is a internal integration that can actually drive collection of this topology, link state DB from all your ISIS and OSPF domains, and also being able to push down the traffic engine path using PCE protocol. We do need a big data collection layer, because anything that you want to do that is aware of traffic patterns in your network would need telemetry collection, right? And in the GNMI-based telemetry collection is the most state-of-the-art, and we support it. We do see that a lot of the networks are still not fully up-ramped to support GNMI. SNMP is kind of the least common denominator. We also need to collect alarms and syslogs, and we need to collect inventory information. So there's a lot of things that we use telemetry layer. And this is implemented as a scalable layer. So depending on how you scale your VMs, your network, you deploy a number of data gateway VMs that will be attached to those devices and collect those. Then we have your configuration engine, which is our NSO platform, which connects to the routers either using CLI or netconf and can configure it. So let's look a little bit deeper on the provisioning aspects. So when we talk about provisioning, we are actually talking about VPN and traffic engineering in IP transport networks, right? So very simply, we can do a lot more things. For example, your day zero config, golden configs, and things like that. A lot of those are already part of NSO, but in terms of abstraction, this is what I'm talking about from the CNC's point of view. And this is done by using a Cisco NSO inside of CNC. And if you let's recap what benefits that NSO brings us and how it brings it, right? It's a model based, and YANG models are used to define the service as well as the device models, right? So there's a little bit of abstraction of how you express your services in YANG models, meaning if it's a L3 VPN, you just need to know the nodes of the names of the nodes at which you're delivering that service, the interface names. You don't need to know the actual configs on the routers, right? That would be the job of the device model, to be able to understand the device's dictionary of how to configure anything. And then there is a translation layer that's needed for a device agnostic model to a device model entry, if you will, right? As a device, service instance data that needs to go on a per device information. All of that should be very familiar to a lot of the NSO focused, developer audience. But just bringing it up, kind of saying that we're using the exact same thing underneath the hood on CNC. The fast map code is what's doing the transformations, and then we can actually talk to more than 170 types of devices because there are nets available for those. Now, one thing that to note is that CNC comes with its own set of NSO function packs, the PSD and core function pack, transport software-defined networking core function pack, which provides you out-of-box L2 and L3 VPN, segment RTT, SRv6, RSPT. So you don't have to start from a zero to build your NSO capability to provision anything. You can start with the core function pack and then just do modifications, which is where the extensibility aspect comes in. So where do you need to extend? You need to extend it in two scenarios. One is that whatever the service model is doing, which is a plain vanilla VPN, you have your own flavoring of it, which is a little bit more advanced. You would want to add a few more things in the router configs, or carry it right from the northbound interface down to the device. So you would add more things in the YANG model. So that would be an extension. That would require a transformation, the fastmap code extension, or a template extension, all that is part of NSO development. You may want to support non-Cisco devices, right? So what we ship out of box covers iOS XR, iOS XE, right? But if you want to do any of our other, competitor vendors out there, your Junipers, Nokias, Aristas, or whoever you want, all of those, you do need to do the extension part to customize the template for that particular device model, and then the code to implement that. So that's something it's done very commonly in NSO land, meaning that if you're an NSO developer, you already know how to do it. And if you're an operations person that is using a multi-vendor network, you have to know that that's possible. Yeah, a lot of our customers do it themselves. We have partners that are doing it, and in this demo, we are going to show an example of it. And in this example, what we're going to show you is that the left side, what you have in this picture, the red parts are what is shipping out of the box. And this is the customization or the extensions that are added, which is the on the right side, which is the orangish thing, which is for a Juniper router that we'll be using in this demo. In this example, we will go a little bit fast, a little bit high level, but if you want to know how the actual package was implemented, we showed this in the Developer Days conference back in November 2022. So you may want to go ahead and look at that YouTube video that I have linked in this slide. Now, one thing to note is that if you're thinking about CNC and bringing it to your in your environment, There are really three scenarios to think about, right? One is that you're building a brand new network, greenfield, that network doesn't exist, now you're building it, so now you'll provision services from get-go using CNC and NSO, right? That's a very simple scenario, meaning you would take all the things that we ship with the CNC, the NSO comes blank, and then you load the CNC TSD and function packs, and you can start provisioning your VPNs and traffic engineering policies. If you find you need more like extensions to it, you can do it, and it's a very minimal effort work. The next thing is you already have running a network, you already have VPNs deployed, but you were using a homegrown tool or some other vendor's tool, or maybe no automation for creating these services. That would be an existing network, but a new NSO, and then on top of it, CNC is coming in. So for that, what you have to do is that first is you install the software suite that we are giving you, which is the NSO and CNC, and then you do an exercise to reverse map your device configs into L3 VPNs and L2 VPNs and the key policies that you have. That reverse mapping, there are some design patterns and implementation patterns you can follow, and of course our professional service can do that. It's usually a one-time effort to create a reverse mapping template because depending on how those things were configured, there's still probably a template or has a little bit of guesstimate and iteration would be needed to create these. So it's not easy out-of-box automation here. But once you do this one-time job, then your state on the NSO is built for all the existing services. That from that point, you manage it from CNC NSO. And finally, if you have already an NSO in your network and you're already using it to provision your VPNs, and you've implemented this package either yourself or with your partner or with Cisco CX that predates the availability of the core function pack, you can still use that. CNC will sit on top of it. There are some additions needed in this kind of packages to give CNC the plan data and the notifications that we need. So there are additional standalone packages that can be added on top of your package to add this, augment this information to your package and send it to CNC. And then this basically enables a current NSO user to get benefits of CNC relatively quick, right? So with that you get visualization, traffic engineering, service assurance, element management that we talked about earlier today. And when you talk about visualization, what are we talking about? How is it going to benefit, right? We'll look in the real live demo as well, but in short, you can see a VPN that is, all the points of where you're delivering service, like a VPN visualization by clicking on a VPN, and all the, let's say, metadata or data like, route targets and things like that can be also rendered. And there is, what we call as decoration that you can add based on the service instance data on this in this UI. When you look at traffic engineering view, which is a bottom view, this is where you can actually click on a traffic TE path and see hop by hop it being resolved and shown on the UI. You can click on details and look at all the, let's say, MPLS labels we're using, SRTE or RSVT or SRv6, you can see the IPv6 paths. There's a lot more in terms of visualization. You can visualize inventory, as it was shown earlier by Paula, as well as alarms can be overlaid, right? Now, the key thing to note is that these visualizations may also need extensions, right? As you change your YANG model for your service, you may want to extend the visualization as well, because what happens is that the visualization follows the service model. And basically, it's it goes and looks at the service model, and then it says these are the routers that are PEs, and it decorates them with those colors and links and these things. And whatever we are shipping out of the box with CNC, it already takes care of the visualization, right? But you can also use your own extension to those YANG models, and in that case, there's a visualization SDK. Either you're just adding more things on the UI or you're changing the YANG model. So those are the two scenarios that you would need to use this particular SDK. That link is clickable to look at our documentation. If you're just adding other vendor routers southbound, the northbound interface doesn't change, so it doesn't need any visualization changes. And then there's a link of what we showed about how to take a YANG model that is not shipping with CNC. So totally independently developed YANG model and a service, and to add visualization. So if you want, if you're interested in that, please look it up. Finally, going into service set, right? So service is something that we added on top of CNC, mainly to help assure a particular service by service, right? Usually the problem is that your operations stacks are built independent of your service turnip stack, which means that your operations team is collecting all kinds of traps, logs, or anything that a router may emit. But nobody is very confident on saying, is this trap going to impact my service A or service B, or is it like impacting my top secret, high premium government or military carrier, circuit that I'm giving? How do you get a service specific assurance, right? That's where we started looking at, how to do this. In the past, it would be to take all the alarms and then try to figure out if that particular alarm on that particular router and that interface may be given to somebody. That's called the mapping server approach, where there's some kind of a data that you have populated saying, this is the config I've given, to each customer. And then if anything comes from those things, that may be an alarm for those. We've changed the model a little bit with RFC 9417, where we took this concept to IETF and debated it and discussed, and it got RFC standardized. The model is that you created the config, meaning the service intent is already known. So that's why you can actually also calculate the KPIs for that service on all the components that are actually delivering that service, right? So that's what is that's why we call it service assurance for intent-based networks, SAIN, SAIN, right? If you think of the service as a in this picture, for example, it's an L2 VPN, depends on like a cross connect status. It depends on the attachment circuit status. It depends on binding to a SR policy or RSVT policy underneath. If you have data path assurance using Y1731 Ethernet SLA, we can actually use that to also feed it into the service state, right? So what we have done is we've built an automation engine inside CNC. What it'll do is, as soon as you configure a service, we know the service configuration model. We have an equivalent rules engine that will map it to a service assurance model, right? As soon as it knows it's a type L2 VPN, it needs to check all of these things using the components that that service is using, like what are the routers, what are the attachment circuits, what are the IP addresses, and so on. And what it does is that it automatically sets up telemetry collection and starts collecting it on a periodic basis. And this is not like hours, but this is more like in minutes, right? Every 5 minutes if it's SNMP, every minute if it's GNMI telemetry. And so it gets all this constant feed of this service-specific telemetry, which it runs through a logic to determine whether it's healthy or not healthy. That logic can be, viewed by the operator to get a view of historical how it's behaving. Particularly if it's a time series data in terms of like delay or packet loss, you can see nice graphs to see how it's behaving. And if anything is crossing a threshold, that will be a threshold crossing alert that's sent so that humans don't need to sit and stare at screens. They are notified when there's something that the system has detected, so you can actually jump in and start looking at it. So we have some references of some information we have shown. What I'll jump quickly to is a set of demos. In this case, we're going to add a Cisco router, non-Cisco router, and we have chosen a Junos Virtual MX router. And in this case, we're going to provision an L3 VPN by using the packages that are needed on SO, and then we're going to show you the service health monitoring. So what are the summary of steps we did in this demo is that we loaded on the NSO side a Juniper Net. That's an network element driver that you can get from Cisco to talk to a Juniper device. We have sample packages that are implementing the L3 VPN and SRTE, and then we are going to add the Juniper VMX router to CNC. Then we're going to provision, and then we're going to also do service health. For service health, we're going to show you that if you're doing open config YANG, there is not much to needed. You just export the rule set that we call it as heuristic package, and then you edit. But if you're doing a vendor-specific MID-based object, you have to actually load the other vendors' MIDs into the system. So I've covered a lot of it. We'll see how far we get. So the starting point for this is that a lot of this will be done in production networks, either through our professional services or our partners, or by yourself with some training from us, right? For this demo, what we've done, we have developed some packages. We have put it on GitHub that you can actually access and see. So this GitHub is public. You should be able to get it. We have sample implementations of provisioning L3 VPN on all these vendors, segment routing TE on all these vendors. And then the way you deploy this on a router is you just pulled out this package, and then you either use CLI to install it, or you can actually sure why it hanged, but yeah. So what I'll switch to in the interest of time is I've already loaded those packages on the NSO. The way you load packages on NSO is very simple. You can actually download those packages and install it, and then wire opt NCS packages, and then you do packages reload, and then the package will show up. So in this case, on the CNC side, we have paired it up with this NSO here, and you see here all the packages that are loaded. And let me first show you that I've loaded those packages. By the way, the GitHub shows you some information on how to install, and there are some post-install steps that are also done. It's all documented in the GitHub README. So you see all these packages are loaded. So that's number one step. The number two step would be that we want to actually map a software type to this particular net, right? So if we go into this, we have a policy or device onboarding policy, which says, as soon as detect a software of type ISXE or ISXR or Nexus OS, you start using these device drivers to talk to those devices. So add this entry to say if it's for type Junos, then you use this net, right? So that's the next step. Then finally, we can onboard the router itself. So if you go in here, I've already onboarded it, but I'll show you the key things to do here, which is, you can click edit, and then you can see here, in this case, the router itself be auto detected using L3, because we are going to onboard the PCE, which is going to get the layer 3 topology. But in this case, you have to go ahead and add the software type and version. We can detect that using SNMP, but usually it's a long string, and we are adding features to let you specify regular expression patterns to pull this information out of those strings, like what show version on Cisco would produce. And of course, you need to provide all the management credentials and capabilities that this router has. At the end of this, you will basically have a topology view with this router added. So in this case, this is the router. And all of these node 1 to 8 are Cisco ISXR 9000 virtual routers. And this VMX is the Juniper V virtual VMX router that's been added. As you can see here, it's detecting some of this through SNMP. You have the alarms here. We have the links here. You can actually click on a link to see that we are actually being able to collect more information about the links, both from Juniper and Cisco side, of what's connected and some of the metrics. Okay, now let's switch to the services, right? So we want to create a service, and I've actually gone ahead and created this service. The way we create service is that you can actually go ahead and use the provisioning screen. Let me quickly show you this screen here. And here are all the packages that are available in NSO are shown. The action, the workflow to create the service is exactly same as you would use for Cisco or non-Cisco. And in this case, what I'll switch to is a window where I have the payloads, right? So we can use an API call, or we can even load the API, the JSON for these creating the service into the UI itself, right? So this is how, if you did it through API, you would create the JSON, right? So you have a IETF standard structure, L3 VPN network, service name. We're going to import, export the same route targets. So it's any to any. And then here's the route policy. We're going to color these routes in the BGP color community. Here's the PEC interface, the VLAN to be used, the P side IP address, the C side IP address. We're going to use BGP. We're going to use connected. And then I'm going to scroll down to the Juniper side, the VMX9, and you see all of the same type of information. There's really no difference here. So let me go back to the screen. So I have it already created because it, in the interest of time. The first thing I want to show you is that if I click on the service, you're going to see a visualization where you're delivering all this service. And like I said, you can decorate this view with any additional information you want. When I click extended overlay, you can see the route targets here. You can go into view details, and then you will see that you have transport tab. And if you go to config tab, you will see that this is how basically I copied that file, the JSON file down. If you use the UI and click through and fill in all the data, then you can go and copy this JSON back, and then you can use that from going forward, or you can give it to your business system that will make API calls to provision it. If you look at transport, this is where you will see the TE parts, right? We colored these routes in with BGP color community, and we also put the segment routing on-demand next hop template, which says that on each head end, if you get a route with the color 4003, bring up a SRT policy for color 4003, which has some criteria in it, right? And you can see we have a Juniper head end here to a Cisco tail end. In this case, I'll just click it, and you can, as soon as you click it, you see the path here, and you can go into view details to see a lot more information about how this policy was created and information that you can see here. The UI is running a little bit slow, not sure. There you go. And then you can see here, let me push this to the side. This is how a dynamic path, on a Junos router looks like. If you're familiar with Juniper, then you will see this is what we are able to collect and show you. The path itself was created using some criteria which you can scroll down and which result in all these MPLS labels, segment labels being used. You can see router and the interface, and then the criteria here, where you can basically use any criteria. This part, it works as if it's the router supports channel-based approach technologies. Now, last thing to look at is service health, right? So you can already see that we are able to collect service health data. You can see the health is good, it's successful. We are using a monitoring setting called bronze L3 VPN, so you can have gold, silver, bronze kind of capability. And if you click on this, you will see, some of the thresholds that we're going to compare against for bronze, which can be different from gold, etc. And then if you go to health, you'll see that everything is healthy. There is no active symptoms, and you can actually go into assurance graph to see that we have a number of things that we are checking, and let's expand all because to show you. And then we have something called soft dependencies. So these are the only things I implemented in this demo, but in reality, it can be anything, any number of things you want. We have two flavors of out-of-box: a basic that checks for L3 VPN, just device health, and then the VRF health, meaning are we getting routes from remote PEs. Now the advanced one checks the PEC interface, like health, like counters, errors, packet drops, BGP sessions, and if you're binding it to SR policy, it will also check the SR policy health. All of this was done by something called heuristic package. So when you go to heuristic package, this is the rule set. You can click export here. These are just JSON files. You can edit them, which is what I did. So I changed the basic ones, customized it. And let me just jump to the device health because we have time to just show you probably one of them. So here's one example of how to collect CPU health from the routers, right? So in this case, this is how the actual metric is collected. So you can see here that there are implementations for SNMP with iOS XR, which is this particular MIP path. It's a vendor-specific MIP. With SNMP with Junos, I have the Junos MIP mentioned here. If you want to do it with GNMI, we have a Cisco-specific YANG path for Cisco. We also have an open config-based path for Junos, right? So the pattern is very simple. You can edit this. It's a text file, like I said, again, it's a JSON file, and then editing this, and then you tarball it and import it back, right? So this is the import-export. This is a kind of pattern you'll be doing: export, test, import, test. And as an engineering team, your team would probably do this and then set it into production. And ops team doesn't have to worry about it. Ops team will basically just use that UI to see just the service health. Now, there's one more step. Because we used a Juniper vendor-specific MIP, you have to load this here. We call it custom packages. So there are custom MIP packages to load. And the pattern to develop this is actually documented in our webpage in the SDK area. If you go to DevNet and look at Crosswork, you feel custom YANG and MIP files. Basically, it involves downloading a bunch of other vendor MIPs, and I have them here. And then this is the basically file, right? If I do a find dot here, you will see that I download a bunch of Juniper and Nokia MIPs. And then you tarball it and load it there, and then you get that. And then the other thing to show you here was the heuristic package itself, which is here. So these are the files that we ended up creating for this particular demo to show service health working with non-Cisco, right? The Junos VMX. So these were the files we did. This is what I had planned, and I know I'm kind of over time here. We covered this. You'll have in the slide. I have a summary of the operational models things here. That's all I had. Sorry for running a little bit over. John, any thoughts, questions?
Well, thank you, Krishnan. Yes, we're a little behind, but I think it was really super valuable information. I mean, we've been saying how the product has multi-vendor capabilities and customization capabilities. All of our customers, typically have some, wrinkle where it's not going to be a complete, Cisco shop, greenfield services, which would be nice, but there's always going to be some customization required, and again, thank you for sharing that. There were a few questions. Let me just hit one that seemed to have gotten a couple thumbs up. Does the Cisco Health functionality support many more checks than shown? For example, TWAMP over VPN or BGP session state. Can you add, additional checks into the service health portion of this?
Yes. So what I showed you was like I said, there are two flavors of service checks that ship out of the box. The basic, again, it's a scale exercise, meaning if you want to do pervasive, just use basic because it does three KPIs. One is the health CPU memory, and the other one is the route counts, right? The reason is that and the advanced one does like about 20 checks, right? Which includes the PC interface health, the PC BGP session state, the iBGP for VPN v4 v6, and the PSEP session if you're using binding to policy. It does add a lot more load to your telemetry and collection. So from scaling perspective, we gave you two flavors. And of course, you can add more checks as you want into it. We have a option to also add TWAMP checks. TWAMP checks with external XCDN-based probes. XCDN integration is available in 7.0, which is the latest shipping release. And in this case, basically, we are able to set up TWAMP sessions from this SFPE or software agent to agent, and then collect telemetry and present it in the same view. We also do embedded for Ethernet SLA. We can configure those Ethernet SLA sessions on the routers itself and use the delay variation packet loss as it's counted. And then there is something called segment routing PM that iOS XR supports. So we also collect that, and we can use that also for.
Perfect. Okay, Krishnan, thank you again. And again, all the decks will be available for review. So I know you went through a few slides at the end there fairly quickly, but those will all be available for folks to take a better look at. So let's jump to our last session for the operations track here. Automating change management with Crosswork Workflow Manager. And Jessie Wayne will be presenting this. She's the product line manager for this product, along with the router automation kit and the cloud native orchestrator and the network function orchestrator. So those are two products that I really love that we have. And Jessie, you'll go through the workflow manager, and I think it was highlighted yesterday. This product, which is standalone, is going to be also integrated into the Crosswork Network Controller. So now it'll become kind of a much more integrated, for some of the different service functions. So a lot of good things happening there. So with that, why don't you take us through the workflow manager?
Perfect. Yeah. Thank you, John. And you're spot on. This is available both as a standalone product as well as part of CNC. So, the value that we're talking about today applies to both. And I'm happy to address that more at the end if people are interested. But to kick it off, my name is Jessie Wayne. I am a product line manager on the Crosswork Workflow Manager team alongside Lou Mendito, and I focus specifically on the router automation kit. So we'll be speaking about both today, CWM and its optional add-on package, RAC, or the router automation kit. And I'll be talking about how you can use CWM to sew together the entirety of your change management plan. So let's jump right in. I always like to start with why we're building this, what we're trying to address. So I've listed out some of the problems that we hear most commonly from our users. And we use this to give us the goalposts for what it is that we need to address when we're planning out and building Crosswork Workflow Manager and RAC. So to begin with, change management remains manual, right? The automation space is composed of different products, which are all very good at what they're intended to do and what they're intended to automate. The gap is that they need to be manually linked, which is both time and resource intensive. So that gives us our first goalpost here, right? We need to be interoperable. We need to build something that's east to west capable and that has a robust set of adapters so that it's capable of stringing together any of the products or individual actors that you have that make up the entirety of your change management plan. Secondly, complexity is an issue in this space, right? So the tools themselves can have high learning curves, so it becomes difficult to get to a point of meaningful use. And because of this, we see users who don't use the solutions because they're too intimidating from the get-go. And we also see users who abandon solutions because they start using it, but they can't get to a point of fluency fast enough. And that's arguably a worse situation, right? Both are pretty bad. And this is a two-pronged problem, complexity, because sometimes what we see is that to address this issue, users create their own change management solutions that are developed in-house. And this works great for a time. There's typically a dedicated group of individuals who've built it and understand it and are capable of maintaining it. But as time goes on, of course, that group might move on. It might become unwieldy and difficult to maintain. These are things we hear about all the time. So we want to build something that is intuitive, right? Usability is something we're really emphasizing, but it can't come at the cost of customizability, right? This is all about people's personal MOPs or specific MOPs to who they are as users. So we need to maintain that, but it should be something that essentially creates an easy button, right? So anybody, even if they're non-tech savvy, can drive the change management process, ideally on day one, right? And finally, vendor specificity. This is something we've already heard about. I'm sure everybody is familiar with it. It's come up during developer days as well. You need multiple tools that do the same thing. So when we talk about multi-vendor, what our goal is there, we need to enable you to leverage the entirety of your tool set, regardless of who's building it. And the same goes for the devices that you're using in the field, right? So how are we going to do this, or what are we going to do with Crosswork Workflow Manager and the Router Automation Kit, right? So this is a good visualization of the relationship between the two. Crosswork Workflow Manager is the underlying driver, right? That is the workflow engine. It's vendor agnostic, and it functions as the thread that ties together your change management process. It's an east to west integrator, right? You're going to hear me say that a lot over the course of this presentation. And to that, you can add on this Router Automation Kit. And RAC specifically is really good at addressing the complexity problem. I will get into that further on in the presentation, but for now, know that RAC is composed of 3 pre-built use cases. They're essentially pre-built workflows: fleet upgrade, golden configuration, and device onboarding. And again, we'll talk about that a little bit later. And of course, both are multi-vendor, right? So yeah, we'll dive into that a little bit more in detail. Let's start with the Crosswork Workflow Manager. So CWM's goal is to ultimately reduce the involvement of your operations team, right? So how does it actually do this? One, it simplifies your repetitive actions, right? So as an example of this, workflows are built to be modular. And again, you're going to see that later on in this presentation in greater detail. But for now, know that the MOPs that you're building out with workflow are pre-tested. They're broken down into very small pieces, and they're easily repeated. And as a result of this, everything that you're using, you've already tested, you already have confidence in. So it becomes easier to build something that's more complex and more sophisticated, but you can still trust it, right? In addition, on the subject of simplicity, it has a nice UI. I've spent a lot of time focusing on usability for that. And it leverages the serverless workflow specification to write workflows, which is both vendor neutral and very intuitive to use. It's also able to validate what you're doing quickly. And what that means is the outputs of a workflow are returned and checked against pre-written policies to enable error and event handling. So workflows can have policies for declaring success or failure. And the results of those workflows can be summarized, which reduces human involvement, as well as the error associated with a human scanning CLI outputs. They can be stored as logs with products like Grafana, and it's capable of metric collection as well with products like Prometheus. It's built to be reliable. So specific example of that, CWM maintains state. And because of this, you can define specific recovery actions based on where you are in the workflow. And that's important because the recovery action that you might take might differ based on what step of the workflow fails. It might also differ based on the use case that you're using here. So if a use case targets the same action for 10 different devices, but only one of them fails, what is it that you want to do? Do you want to roll all 10 of them back? Do you want to roll one back? That answer can vary, and you're going to have control over that. In addition, workflows can notify management or messaging system of specific notifications, and they can be paused for approval. And this is something that we can emphasize with operator dialogues, which are introduced in CWM 1.2. I'll get into that a bit more on the next slide for more detail. And finally, of course, it needs to be an east to west integrator. That is the core function of any good workflow manager, right? So with that said, this slide visualizes how CWM automates broader change management rather than just the distinct activities, right? Like this is CWM functioning as that east to west integrator. And what it's essentially doing is lacing together all of the different automation steps, all the different products that you're using that compose the entirety of your solution. So like I said, east to west capabilities, all of these products are fantastic at what they do. They tend to exist in silos. So our goal is to create an easy button that implements the entirety of your change management plan so that you no longer need to manually link together the individual steps here. That is, of course, supported by a robust set of adapters. Adapters are really the meat and potatoes of how this works. So CWM and the adapter front provides a number of prepackaged adapters for general use. It also has one SDK, software developer kits, as well as something called XDKs, which are new with CWM 1.2, or extended SDKs. And these are used for the auto generation of specific adapter activities. So adapters for outbound integration that come as part of CWM are the generic DB adapter. And what that does is it adds the ability to integrate with databases like Postgres and MySQL. It has a set of custom adapters that you can build, or I should say it has an SDK that allows you to build custom adapters based on, there's an NSO adapter, but also based on REST, CLI or SSH, and email over SMTP. And finally, with these XDKs, these auto-generating adapters, there is an XDK for both NSO services and NSO actions, as well as an XDK for OpenAPI. Now, in addition to this, CWM offers event handling and error handling. So for event handling, we are integrated with Kafka using AMQP and HTTP protocols to handle external events. And this means that CWM can handle incoming and outgoing events both. So incoming prompts can start a new workflow. For example, you can trigger a workflow from another product like CNC. On the other side of that coin, outgoing prompts from CWM can signal a start to other products like CNC, HCO, whatever else it is that you're trying to signal. So a good example of this are the operator dialogues. This is where I'm going to dig into those a little bit more. So operator dialogues are essentially pauses for input within your workflow. And what it does is it validates pre-checks and post-checks, requests additional inputs, requests confirmation to proceed, and provides a consumable summary of the workflow, of the relevant information. And it does this, it's interactive, right? It's doing it with your user, but something you can do in a demo that we've actually built is a WebEx bot with CWM using Kafka that can solicit all of the steps I mentioned, like requesting confirmation to proceed, et cetera, from the user and even from their phone, right? But you're not bound to just WebEx. Any chatbot that you want to use can leverage Kafka events. And like I said, it unlocks a lot of flexibility on your part, right? I think I said just before, now you can do something like this from your phone. And really, these operator dialogues represent inflection points in your workflows process, right? So earlier on this track today, you heard Javier speak about the need for proactive decision-making, leveraging the AI tool set to enable that. And in the future, these natural pauses could be good places to implement ML-driven decision-making tooling, right? It's another opportunity to have less operator involvement. It doesn't exist yet, but it's certainly a good use case example of what you can do with these pauses. Finally, let's talk a little bit about error handling. So CWM is capable of both reversal and compensation. And what that does is it allows you to define what should be done to compensate for whatever kind of error has been made. And each step of your workflow can have specific compensation logic assigned to it. And it also has extended logging. So workflows are capable of generating their own log entries. And to close this slide out, it's a good moment to talk about why CWM is very well paired with NSO. And again, it links back to this concept of east to west integrations, right? CWM implements your change management plan. It gives visibility into status, input request permissions, it gathers data, pushes data, whatever it is you're trying to do. Then NSO can act on that, right? That's the intent-based system. We hear intent-based used to describe NSO all the time. And NSO from the CWM perspective is what provides multi-vendor ability. It drives a lot of the error and exception handling. It offers dry run capabilities. And when you link CWM and NSO together, CWM can link NSO with other software, and it ultimately becomes the entirety of your change management process. So, for example, now you're capable of accessing info from other databases, like configuration management data from things like MySQL and Postgres. And, it's really about the whole picture here rather than any individual step. That's hopefully what the visual on this slide is communicating. Okay. So I also want to take a moment to talk about workflows as modular elements. So workflows are essentially building blocks, the way that they're put together in CWM. So what that means is you can build a series of small, distinct workflows that you can then assemble into a larger parent workflow. And this allows you to build, elaborate workflows that are very easy to maintain because ultimately they're composed of these smaller pieces that you've tested, used, and stored. So these are all pieces that you already trust, right? You're lacing together all the different automation steps. It becomes easier for the operator. And ultimately, the more that you trust these workflows that you're using, the further you can walk away. So if we look at this, this visual here, we have the workflow library on the left, and that shows three different, actually call them child workflows. These are three different pre-built workflows. You as the user can take these workflows, assemble them into a parent workflow, test the parent workflow, archive it, add it to your workflow library, and then of course, start the job. Because again, they're modular, they're reusable, you're ultimately confident in the actual operation of the workflow. And in addition to that, these pre-built workflows can be expanded by adding pre-execution or post-execution logic. For example, rack fleet upgrade, you'll see how we use pre and post checks on top of the classic fleet upgrade flow. So if a customer builds a custom mop, their mop can then be modularized and reused elsewhere. It can even be used as part of a different parent workflow in the future if needed. This is also a good moment to call out some of the organizational tools that are available with CWM. I mentioned earlier, it has a nice UI. It also has the workflow library here, which allows you to store the workflows that you built and tested for future use. It has the job manager, which allows for tracking of the scheduled, running, or completed workflows, as well as visualization of the execution details. It has tagging capabilities, so you can tag and sort your workflows however you'd like to. And finally, calendaring and scheduling as well. Okay, so what's new with CWM 1.2? We already talked a little bit about the operator dialogues. These dialogues are natively hosted on CWM, and there is a form designer that's provided for creating these dialogues within CWM. I also hit a little bit on the adapters. There are some new adapters introduced with CWM 1.2. In the XDK department, you can now generate activities representing NSO actions. So that means XDKs can now generate activities for NSO actions as well as NSO services. We also introduced the generic DB adapter, which allows you to interact with external databases like Postgres and MySQL. This enables you to read from a database as well as write persistent data to a database. Input schema validation, what this essentially means is the JSON input data for a job is validated against its input schema definition. And if needed, the job will then fail with an error for invalid input data. Wei Tai actually showed an adapter that he built for this in Stockholm, but it's now built into CWM. So if you were there, you already saw a little bit of the value behind having something like this. And finally, we've upgraded Kafka to 3.3.2. So that was a bit on CWM. Let's talk now about RAC, and I'm going to reflash the challenges and solutions slide here, just to refresh your memory. And I want to call out the complexity space specifically. If you remember at the beginning, I talked about how high learning curves lengthen the time to value for different automation products, right? So we're trying to build something that's intuitive and ideally usable on day one. Something that somebody who is not tech savvy can sit down and push a button and say, okay, there it goes. I trust that this is happening. And that's exactly what we're trying to do with RAC. So Router Automation Kit is this optional add-on to the Crosswork Workflow Manager. And it is composed of these 3 out-of-the-box use cases. So that's Fleet Upgrade, which is an image and OS upgrade workflow, Golden Configuration, which is an auditing and remediation workflow, and Device Onboarding, which is a provisioning workflow. So let's talk a little bit about RAC Fleet Upgrade first. So you can see from the visual here, Fleet Upgrade itself is essentially a parent workflow composed of several distinct child workflows. And some of the standout features for Fleet Upgrade is, one, it has a use case specific UI. Why is this important? It's dedicated to the specific use case, which means it's designed to walk you through the process, right? You don't need to be particularly tech savvy to get meaningful use out of Fleet Upgrade because of this. We've really emphasized usability here. But just because it's intuitive doesn't mean that it sacrifices customizability, right? You can see here I have the mop builder listed. It actually comes with 2 out-of-the-box mops, but the mop builder allows you to implement your own custom processes, depending on, everybody tends to have their own mop, right? So it's important that we support that. We also have software conformance checks, which enable you to select and enforce specific image policies that you can define. And we have these custom pre and post upgrade checks, right? And the pre and post upgrade checks, what they're essentially doing is comparing the differences between, the pre-checks and the post checks to ensure that you're only committing the expected changes when you're undergoing this upgrade process. And those are customizable. You can build whatever commands that you want into those checks. Finally, multi-vendor, right? You're going to see this across all of the use cases for RAC. Fleet Upgrade supports third-party devices, and the goal there is you only need to use one solution rather than many that are doing the same thing. And this is something we're really committed to. We are planning regular adapter releases that are decoupled and more frequent from the product releases so that we know we're regularly adding to the list of supported devices. Juniper is our next upcoming device support and our next release for May of 2025. And in the future, to close out Fleet Upgrade, this is a space where you can, again, implement ML-driven optimization tooling to make specific recommendations on what you should do with your upgrades. So, for example, recommendations on specific SMUs or P-certs, when you should schedule them, things like that. This is a quick sneak peek at the UI that we had planned for our next release. So this is for Fleet Upgrade specifically. If you were around yesterday, we actually gave a demo of this. Sri did a great job presenting and giving a walkthrough of this. But what you can see is on this first page here, we're looking at the list of devices. You can see, for example, there's some reports on the conformance checks, non-conforming or good to go, where they are in their fleet upgrade status. And along the top bar there, you can see there's a local image repository. We are also capable of integrating with things like CCO. There are the software conformance checks themselves, the MOPs that you have defined, as well as the jobs that you are running. And in this case, you can see that it's visualized as part of Crosswork Workflow Manager. But as noted at the start of this presentation, it's also something that's going to be available as part of CNC. In which case, it's the same UI, the same user experience, just housed within CNC. Okay, Golden Configuration. So what is Golden Config? This is an auditing and remediation tool, right? So ultimately, users can apply templates of any format to provision devices with their desired configuration, right? So it offers things like historical configuration records and scheduled audits. And it offers remediation actions as well. So for example, template reconciliation and redeploy template to make sure that everything is configured as you expect it to be. Template-wise, users can leverage C-style, which is associated with XR, J-style for Juniper, JSON, or XML, as well as these native device configs and Jinja 2 templates. And if you're not familiar with Jinja 2, this is a templating language that helps users simplify what would otherwise be very complex configurations by having them define a minimum set of parameters. And finally, it is also, of course, multi-vendor. Golden Config already supports Juniper and Arista. Okay, and device onboarding. This one's pretty straightforward. We're automating the boot image upgrade and installation of your day zero configuration. It currently supports classic ZTP. It onboards the device into NSO, for example. And this can be used as a child workflow in a larger workflow. Again, we're talking about weaving this into a broader change management plan, right? So this is something pre-built, ready to go for you. And it also whitelists expected devices. This is a security measure, right? So nothing is going to be onboarded that you're not expecting to see there. And again, multi-vendor, right? We currently support Arista for device onboarding, and that list will grow. Okay, so where can you learn a little bit more about both CWM and RAC? So CWM, if you were in Stockholm this past May, you would have seen both the CWM introduction and demo and the RAC fleet upgrade demo, which I have on the top column there, or the top row there. We also have a CWM demo onboarding a virtual router to AWS, as well as building a utility function adapter for CWM using those SDKs. There's also a good demo of customizing the RAC workflows, right, to build them to or implement whatever MOPS it is that you're using. And finally, there's a great Crosswork automation and sustainability demo, which showcases WAY, CNC, CWM, and NSO. Lastly, where can you get CWM 1.2 as well as RAC? They are co-housed, so both are available on software.cisco.com. RAC is available there as an add-on to CWM. All of the documentation for both products is available on cisco.com. And then, of course, there's a great community around support and resources on both DevNet as well as community.cisco.com. So thank you so much. This is everything I had.
Great. Thank you, Jesse. Really exciting stuff happening with CWM. I mean, it's a fairly new product. You know, I think it's less than a year old or about a year. So it's really great to see, you know, all the new things that are getting added into it. So great job. I do have a couple questions, and I do have a poll set of answers. So the poll, which use cases are most exciting to you? And fleet upgrade was 18%. Golden config was 64, and device onboarding was 18. So
Okay.
Is that consistent with what you've seen from customers?
The golden config is a surprise. That's definitely a popular one, but typically it's fleet upgrade that we get a lot of, we hear a lot about. So it's good to always, you know, hear from the audience what it is that's interesting to them.
Yeah.
Yeah.
So here's a few questions that the folks were asking. Do pre-built use cases come as part of CWM?
Yeah, so that is RAC is an add-on to CWM, right? So Crosswork Workflow Manager, from a licensing perspective, there's CWM Essentials, which is just CWM, and then there's CWM Advantage, and that gives you access to both the SDKs as well as all three of those RAC use cases.
Okay, great. Is there a plan to add a UI for golden configs?
Yeah, so you mentioned this already. RAC is pretty young. It just launched. CWM is a little bit older, but RAC was just launched this past spring of 2024. So our next release is going to introduce that UI. I gave a quick preview of that for fleet upgrade, and golden configuration and device onboarding will follow in the subsequent releases. It's important for us to get those UIs out the door.
Okay, perfect, perfect. So yeah, that's all we had for you, and I guess we can now get into our wrap up. So please stick around, Jesse, if there's anything that comes up in the wrap up. But I guess let's wrap up. And if there's any additional questions that the audience has, please shoot them into the Q&A and or chat. And let me just kind of recap what we heard today, and also encourage you to fill out the survey, because one of the things we try to do with this event is make it better every time we deliver it. And we have the event in December, typically more on the Americas side, but then a global event in Stockholm. And as you can see here, that will be in May of next year. We've been doing developer days for, at least 10 years. And, we've been trying to improve it. And, one of those improvements was breaking out a developer track and an operations track. So we heard you there. And, any other things that you think we should improve on, please let us know in the survey. So in terms of kind of what we heard today, I think it's a little bit for everybody, right? So some of you have been with us for a long time, for 10 years, and some of you are new. But I think one of the takeaways I heard was, if you remember the first session today from Javier on AI for network ops, we all know this thing called AI is coming, right? It's coming strong at us, and there's going to be a lot of really fantastic use cases that are going to develop over time. But in order to get to that point, there's things we're going to have to do in terms of modernizing these networks from an automation perspective. Using the products or tools similar to what you heard today. Just magically, AI is not just going to work in your network. You're going to have the proper data collection tools, to get all the telemetry from the network, and you're going to have to figure out how that is, mapped to the services and the configurations. If you want to do anything interesting in terms of closed loop automation and moving traffic flows around, so all the tools like the workflow engine, the network controller, the planning tool, those are all under the hood of how the AI systems will eventually work with the network. So it's important that we begin to modernize and begin to develop using these tools today. And you can do that with bringing these into your labs or into your networks to kick the tires. I think the local account teams are more than happy to work with you to demo and to proof of concept these things to see if they meet your needs. So we're more than happy to for you to try them out and then decide if they're going to work for you. There were a few questions that we didn't get to, that I want to get back to because we still have time here. Krishnan, since you kind of went a little over, so we didn't get to all the questions that were being asked for your session on the customization pieces. And are the packages, all the packages you reference, are they available on GitHub for use?
Yeah, so the package that I referred to where we download GitHub, that's basically where we are keeping all our, let's say, sample or demo grade packages to work with other vendor routers. That can be your starting point. It's you can access it, but usually either you have our professional services or partners working with you to test in your lab and then take into production. That's what we would recommend. For service health packages, you could export, edit yourself. Again, with a little bit of training, anybody should be able to do it. I think what I would say is that what we showed today, we can definitely share it, but to work with as part of the integration test, when you have other vendor routers with the specific configs, a lot of the time, I would say 80% of the time goes in just figuring out what are the let's say, set of configurations you want, and even more time on figuring out the SNMP MIBs or YANG path that will tell you the status, and then building the HP itself is not too long. But yeah, the samples are available as a starting point, more testing in your labs, and then go to production and have CX help you with that.
Okay, great. And one last one for you. Can all of the service health functions work with GNMI? I think this is a good one because, obviously, GNMI and SNMP are the two approaches that the industry is using to pull telemetry off of the routers. And I think the ball is bouncing towards GNMI. It's more efficient. It's more programmable. I was on a call recently with a customer who said they don't want SNMP. They want to just completely get off of SNMP. So I guess what's the answer there? Do all the service health features work with GNMI?
Oh yes. So from CNC perspective, that would also be our preferred approach, is that use GNMI, because GNMI is definitely more helpful to the controllers, because you don't have to send a SNMP pull packet and wait and lock a lot of compute resources on any kind of collection infrastructure we build. And everything from the CNC side that we are shipping with the out of box, I would say everything, but maybe 90% of it is GNMI based. But we do have SNP for things that are not supported with GNMI. That's a big problem with GNMI, is that the set of YAG models that are available for operational information is not as pervasive. And even if it's pervasive in a vendor, meaning even if it's rich in a vendor specific context, the open config version of it's even lagging behind, meaning the open config versions of some of the operational models are coming even slower, right? Depending on the industry interest. So from the CNC side and collection, we prefer it if it's available. And really, SNMP should be only used where you're not getting the same information, where GNMI, and you may even find that you have to do some CLI scraping. We do have some libraries and frameworks where you can plug in CLI. Today, we don't offer that as something that customers would do themselves, so for some good reasons. But our CX can implement, let's say, seed implementation of some CLI if both GNMI and SNMP didn't work for whatever reason. So that's it's not really performed at all, meaning the number of collections you do, we would recommend go with either a lower cadence or less number of devices per collection VM and so on. SNMP is scale of order better, and GNMI is scale of order better than SNMP. So
right.
Yeah,
if you're building this from scratch, you're going to go right to GNMI, right? But
yeah,
again, we have to be able to support existing networks and multi vendors that may not have other vendors that might not have certain capabilities. So I guess we support all the options. Thank you. Julia, two questions. The first would be crossword planning. Can crossword planning deploy optimization changes to the real network using APIs? Which is actually a really great question because, you know, when we start thinking of, you know, the future with AI, I see crossword planning and the optimization engine as instrumental in how closed loop will work. So I guess can you deploy changes into the real network using APIs from crossword planning?
Sure. Thanks, John. Yes, so actually that is a good question. So as we saw in crossword planning, we have these all Python APIs, right? So there is nothing that stops us like to build a script and use those APIs in order to maybe build a sequence of the recommendations provided by crossword planning and then deploy into the network. However, because we are also aligned into the autonomous network framework, right? So I think that the idea would be that we need to have a controller or maybe an orchestrator that will be communicating with the actual network and do the provisioning, right? So in this case, crossword planning should be acting as an offline tool, maybe build all the recommendations and then via API communicate to the controller or to the orchestrator, and it should be the functionality of the orchestrator to provision into the network, right? So this is the way how it should work.
In our case, that orchestrator would be CNC.
So the controller could be CNC, or if customers have NSO in place, it could be also NSO, right? Or workflow manager, why not?
Okay, great. And a quick one, does crossword planning also expose REST APIs?
Yeah, so that is a good question also. So actually today, crossword planning does have some REST APIs, but those APIs are mainly to set up the SDK client. So there are only few REST APIs today. But yes, we are planning to add more APIs in the future, in next releases, in order to expose the simulation tools of crossword planning, and why not also to access into the network model. So that is in our plans. Okay,
thank you. Jesse, we have one question for you. Are non-SP use cases in the roadmap for RAC? Example here is integration with full stack observability tools. I'm not sure if that makes sense, but does it make sense? I mean, non-SP RAC use cases.
I mean, the way that we're prioritizing the use cases is we're looking for things that are commonly used across our group of users, right? Our customer set. And so that doesn't necessarily mean that we're limited, we're not going to do non-SP. It's really use case specific, right? Like what are the functions, what are the things that our customers are doing all the time that they really have a need to automate and have an out of the box use case for? So I suppose the short answer there is no, it's not limited. We could do non-SP use cases. It depends what the specific use case is, right?
Yeah. I mean, workflow, it's whatever the user wants to do, right? And, you're providing the tools and whether the network is an SP network or an enterprise network, it's still a network that needs to be upgraded and controlled.
Exactly.
Maybe the question was more around like things like, wireless access points or things that you typically would get in an enterprise network versus, the typical router SP products. Okay.
And to elaborate, just you were hitting the nail on the head there. Remember we're talking about two different pieces of this, CWM and RAC. CWM, you can do whatever you want. You take that, you build the workflows that you want to build. RAC is those prepackaged out of the box, use it on day one. So that's the distinction there of, what are we going to build versus what are we going to enable you to build?
Okay.
Yeah.
Okay, great. So I don't see any other questions. So I guess, let's just wrap up here. And again, I want to thank, everybody, especially the end customers, end users who are on the line and stuck with us on this. Hopefully it was useful. I think, again, it's a little bit for everybody. Some of it's a bit overwhelming fire hose, but the hope is that send us your input, send us your feedback. We'll try to do more in the next session. We hope you can join us in Stockholm. I usually go to Stockholm, even though I'm America's based. I'll go to Stockholm. It's not just a European show; it's a global, and a lot of the automation team is based in Stockholm. So you get the actual Cisco developers who are there. Stockholm's a beautiful city, so definitely try and make it. Again, this is a journey, so you need to start somewhere. We can start with something simple, and then over time we'll work with you to get to the final objective, which is the autonomous network, AI driven system. But hopefully these tools and these products and the multi-vendor aspects of them are going to be something you can leverage. With that, I guess it's a wrap. Thank you again, and have a great holiday. And again, thank you for attending and being a good Cisco partner. Thank you.
Cisco, our purpose is to power an inclusive future for all. And in that future, Mother Nature has a voice.
How have things been at work?
It's Groundhog Day. Just always the builder, never the architect. But the thing is I've got ideas. Big ideas about better products, new revenue streams, smarter investments, but the thing is I can't focus on any of that because here I am too busy playing whack-a-mole all day.
It's a lot of metaphors today.
Thank you.
So it sounds like you need a platform that drastically reduces the amount of confusion caused by zillions of analytics tools and focuses the data for you.
Something that allows me to spend time thinking big picture.
Something that would reduce the amount of app system errors, pinpoint areas of improvement, and proactively suggest fixes.
Exactly. Why do you know that?
Don't know.